Hi, Boris. How are you
Hey,
doing?
hello, Jelte. I'm doing great, even though it's super early in the morning. I think it's like 7 a.m. in UK or Portugal, but we are ready here to bring you some extra excellent content for Posette, and I'm super happy to share the stage with you. We did it already once together with Floor Dress in a meetup in Amsterdam for Halloween, so that
Yeah, it
was
was
super
super
great.
fun. Yeah, I,
Yeah,
I
but
remember. I remember I was wearing like a werewolf mask. That was
exactly.
really fun.
Oh, super fun. So please, Jelte, enlighten us with what is going to happen today.
So yeah, first, welcome everybody. I hope you're a bit more awake than we are, but we'll get there. So yeah, um, let's talk a bit about what Posette is for anyone joining just now. There's 4 live streams, and you can watch some recordings later. But there's 4 live streams, and we're in the last one. So if you missed the previous 3, if you go to Posette schedule, you can watch them all back. You can find the links there, and
Yeah,
otherwise it's in Discord. All the important stuff is also on Discord.
and there is something that catch my eye attention there because I mean, why are there 42 talks? But it's split like in 11, 11, 10, 10. It would have been easy to have 44. Does this have something to do with the great answer to the ultimate questions of life, universe, and everything?
I mean, I kind of
Maybe.
has to because
Yeah,
yeah, now we only have 10 talks to watch instead of 11 like our previous co-hosts.
exactly. Yeah. So who are we?
Yes, I'm Jelte,
And
and
I'm
this is
Boris.
Boris, and we're yeah, and we're the hosts of this show. But I mean, there's also the other
Yeah.
people from the other hosts, and Claire actually
Yeah.
did two shows.
Yeah, and there's something that Claire didn't want me to tell, but I mean, I'm going to say it anyway. Sorry, Claire, for disclaiming this. But she had a very nice list of people to do the live stream for, and all of them canceled. And then she and Teresa, they have to go, well, we have to do with Yelta and Boris. I mean, if they want
Yeah,
to do it,
yeah,
why
yeah.
not?
Because our yes, our chemistry is terrible. So it's
We'll see.
we'll make it
So,
work, but it's gotta. I mean,
apologies for the inconvenience. Yeah.
yes. So yeah, let's talk first quickly about who organized this. Like, I'm working for Microsoft, and it's our team at Microsoft that organized most of this conference. But it's definitely not just made by Microsoft, and it's just not just for Microsoft people. It's lots of the speakers are not for Microsoft. Lots of the content is not at all about Microsoft related things, except if you call
Exactly.
Postgres in general a Microsoft related thing, which it also is because we host Postgres, but many other people do as well. So, but there's it's content for everybody. There,
Exactly.
it's just a general thing that we like to
Yeah.
do for the Postgres community.
And one of the things that I like from that is the fact that it's really meant for the community, and that's one of the reasons why I work for EDB. I can participate in this not just as a speaker but also as a co-host. So this is a whole thing for the community, which I really like. So happy to be here. Yeah.
Yeah, great to have you, Boris. So yeah, the reason, the main thing about this conference is that it's about making great Postgres content available to everybody. Because I mean, I like going to conferences. Traveling is fun. Seeing people in real life that you maybe have never seen before is fun, and speaking to them face to face. But
Yeah,
not everyone can do that.
and if you think about that, if you were able to be in Prague last year in December for PGConf Europe, there was a keynote by Simon Ricks, which we all miss, and he was mentioning the value of online conferences. He was saying, like, look, this is the largest PostgreSQL conference that we had, and it's about 800 people, but it's just 800 people. I mean, you say, like, well, 800 in a person's event is super large, but I mean, it's just 800. He said, if you go to an online conference, you can reach a lot more people, a lot more audience is going to be able to see your stuff, not just when you're delivering your talk, but after the talk. And that's one of the things that for me gave me think like, yeah, I really need to make an effort to push more of my talks into a online event and attend online event and interact with the people, because we are able to reach people from South America, which I am from South America, much easier with this, because traveling for us is much complicated to get to the northern part for conferences in person. So this is super good. This is also one of the motivations for me to be here. Yeah. So thank you, Simon. We miss you.
Yeah, I also definitely remember being a student and it's just expensive. Like even if the ticket is cheap, it's like made cheaper. So, I mean, it's 50 euros. I mean, to me, 50 euros, it's like, I don't know, a lot of beers. So it's when I was a
And
student,
lunches.
you need to buy a plane ticket or a train ticket and a hotel or a hostel, and it's so that it adds up. It's really nice if you can just walk these talks for free.
Yes.
So yeah, we also have a code of conduct, like most things nowadays. Basically, it's be excellent to each other, be friendly, be patient, be curious. Think about how other people feel. If you
remember the golden rule. Yeah.
Yeah, but the golden rule is just be nice to each other. That's sort of the overarching theme. If you want to read the whole thing, you can go to the link on the screen. But yeah,
and that also holds for us. I mean, if you think that we are saying something that is not appropriate, you can always contact the Code of Conduct committee and then say like, okay, please, it would be nice if this doesn't happen again, because we might make some mistakes, but we want to be aware of the fact that we can make mistakes so that we can learn also from that. But the Code of Conduct is for everybody, not just for the people that attendees in Discord channel, but everybody. Yeah.
Yes, yeah, totally. Also for the speakers, but especially for us. Make sure to keep us online.
Yes.
So today we'll have some live captions. They're in English, but for like everyone else that doesn't have English as their first language, we'll also have translations on the recordings after the event.
Exacto. Tenemos en español. Si quieren ver los subtítulos en español, van a estar disponibles. Así es que para ustedes también todo el contenido.
Ja, en ze zijn zelfs ook in Nederlands. Dat is een van de 16 die er nog, de 2 die er nog bij komen.
Perfect.
And we have a hashtag, of course. If you want to tag Posette, make sure to use PosetteConf, not just Posette, so that all the things are sort of listed together. You can use it everywhere that you might want to use a hashtag. Yeah, use the hashtag whenever you post.
For the content to be spread everywhere, so that people is more aware of the event. Yeah.
Totally.
Yeah, mostly, I mean, Mastodon, the formerly called Twitter, and Threads are the most predominant, how I say, like prominent. Those that are most used. So contact people through socials in there, and I'm definitely in Mastodon. From time to time, I'm also in the other one, X, and I have to explore Threads. Actually, I haven't had a look at that one yet, but I will be there. Yeah.
And yeah, they're like the at like the account for Posette is @PosetteConf, just like the hashtag is #PosetteConf. And now we just want to thank all of our speakers. As you can see, there are a lot, and both me and Boris were also speakers. So now, like, the speakers are the ones who are important. I mean, right now we're just the people that talk a bit in between the talks to make sure there's no awkward silences. But like the speakers, that's what you're coming for, not just for our light banter.
And look, some people ask us whether this is a bingo. I mean, like when you finish looking at all the speakers, like you do tick on the faces, and then you shout bingo in Discord, and you get some swag. That's not the way of getting swag. There is some other information. So how you get stickers and socks and all the stuff. But it's not a bingo. It's just a nice board of all our speakers.
Yeah. And apart from the speakers, there's also, we wouldn't have any of these speakers if we didn't have the talk selection team. They spend a lot of time going over all the submissions. It's really, it's really normally thankless work, but that's why we want to thank them now. So it's thank you, all 4 of you, going over all these talks and finding the best ones and sort of making good matches so that it's not just one topic that will cover this conference, but sort of a nice mix.
Absolutely. And to enhance that feeling of being an event for the entire community, for all the people to submit talks, there is also a blog post written there that you can have a look at to see how the process is being done for selecting the content. so that you can fully trust that this is for the community. So
yeah, because
thank you,
as you might
Alicia,
see,
Claire, Daniel, and Melanie. Yeah,
as you might see, these are all Microsoft employees, but they really made a they made it very clear how they submitted talks, not just from Microsoft people. It's definitely there's definitely lots of people that are not from Microsoft that have talked to it. And we wouldn't be here also without the organizing team, especially Teresa, who's been doing so much behind the scenes, making sure everything runs smoothly, so that we can just wake up this morning and sort of go babble on about stuff. Thanks Teresa and all the rest. You've been great.
Something special you have seen that there is a common theme within all the first name, Teresa, Aaron, Ariana, and Erin. You need to have kind of 2 syllables connected by an R in your first name so that you can be there. So this was known secretly inside Microsoft like the pirate organizing team because of the R. Yes, which is probably one of the favorite letters of the pirates.
So yeah, and don't forget, all these talks are already pre-recorded. And you might be like, wait, why am I joining a live event then? Well, it's because we have a Discord channel and the speakers of the talks are all there. So if you join the Discord while there's a talk, you can ask the speaker questions. So it's really nice that it's pre-recorded because now the speaker can answer your questions while they are also talking at the same time. And after the talk, they will still be there to answer some more questions that you might have. So be sure to go to the Discord channel and
we are going to be there actually as well, talking with everybody, looking at your questions. If you have something interesting to say that we think like, this might be something that everybody should know, and then we will comment it also to the other people. So use that as the way of interacting with the rest of the people. I think there are like 1.2 million and the people in the I'm terrible with numbers. There is a smaller number than that, but there's a lot of people in Discord now. So join the community and then talk to everybody, and we're respecting, of course, the code of conduct. Yeah.
So yeah, I mean, we already kind of said this. If you have questions, go to the Discord. But we have 2 slides for this because it is one of the most important things in this slide deck. So yeah.
Yes, because you could also ask questions on social by using the hashtag PostsetConf, and then like if you want to put the question on Mastodon, so that the speaker can answer in Mastodon and it doesn't disappear only in Discord. That's also another way of doing it. Yeah.
Totally true. Be sure to also mention that you did that on Discord though, so the speaker knows that it's there and doesn't miss it. But yeah, if you want some swag, this is what you should do. There's a code and a link in the video right now. If you want stickers, then go there and we'll send you some stickers your way. That's kind of that's or
don't shout bingo. Yeah, it is. This is the way of getting the swag.
Yes, this is the way of getting the swag, and because we're missing that. Like at this virtual conference, that's one thing that you miss. You miss all the booths with all the stickers and all the swag. So this way you can still have some stickers to put on your.
When you ask people, it's like, why don't you attend to online conferences? They say, well, they don't have swag. And it's like, where are the booths? Yeah. So, but this fixes stuff. I mean, if you want to get some swag, this is the way of getting it. Yeah.
And if you want some even more special swag, t-shirts or hoodies, you can. At Microsoft, we have 2 challenges that you can join. One for AI and one for migrating and configuring Postgres on Azure. And if you complete one or both of the challenges before June 24th, you can win one of the hoodies or t-shirts, maybe even end t-shirts. I'm not super sure, but you get fancy clothes. Or just
exactly
doing like a little challenge and learning a bit about AI or migrating to Azure. And yeah, the link is on the screen, the Posette CSC short link. And if you don't know,
so
Boris, you go.
Somebody asked me this week. It's like, oh, I want to see the live stream of Posette, and then I don't know where. And they said, well, I just sent the link to the ultimate guide, and it was not just information about the live stream, but also how to join Discord, how to see information about the speakers, how to get the swag. That's the ultimate guide, and the great answer to that question about how you join Posette, it is here in this blog post. That's the ultimate guide for you.
And you can see there that we have tons of talks, some AI, some core Postgres, some ecosystem talks. This actually doesn't add up to 42, so some get double.
Yeah, this one adds up to 46 or something like that. So please tell us in Discord, why do you think that this one sums up to more than 42 if there are only 42 talks? Huh.
We
These are the
we have
keynotes.
some, yeah, this is the keynotes. We have some amazing keynotes. There's been 3 already. They were all amazing. And we'll have a 4th one coming up shortly.
Yep. And this is very important.
Yes, very important.
Feedback. Yes. So I want to comment something that we were having a discussion between speakers, and then we were saying like, yeah, well, I didn't get that many feedback, and it was nice to get that because you can improve your presentation. And then it was all a kind of a chat between speakers. And then I asked the question, so did you guys submit to all the people? And it was kind of like, well, more or less. I mean, speakers, they can give very good feedback to other speakers, because for us, it's kind of a hard job to get everything right, so we know what we struggle with. So if we can provide that feedback to other speakers when we see other people, I mean, that's super important. So if you are a speaker in Posette or another conference, you're even more encouraged to provide feedback to the other people. Now, if you are participating as an attendee, you can also provide feedback to the speakers and the event itself, because we want the event to be better next year. Because there is going to be a second edition of Posette. They promised me. They said, I'm not going to be a co-host if there is not going to be a second edition of Posette, which is going to be the 4th edition of this, if we count the CitusCon before. But I mean, the only way to get better is to get some feedback. Otherwise, it's just like well, I think we did that good or not. Getting the feedback from the people is the best that we can have, so that we can improve for the audience, and the community, of course.
So you know what, Boris? I think you're totally right. So I think we should do like a little challenge. You know Lord of the Rings, where Gimli and Legolas do like the dwarf fighting and counting how many the orcs. Sorry, not the dwarf fighting, the orc fighting. Yes. How many orcs they've slain. Let's do that and challenge each other and the rest of the whole Discord to do as many talk surveys. Right. Submit as many talk surveys and feedback as they can, and see who wins.
Okay, let's see who wins that one. Good challenge taken.
We'll do 10 talks in this live stream, not 11 like in live stream 1 and 2, because that adds up. Now it adds up to 42, and we're gonna have a lot of fun. To sort of show you a bit what's going on, what's going to happen in the next few hours. We have a little video to sort of get you warmed up for all the talks. So let's play that now.
My name is Thomas Munro, and I'm going to be talking to you about the Postgres project, or PostgreSQL, where it came from, what sorts of things it does, how it is made today, who makes it, and a bit about how I myself got involved in it, and how you might get involved in it if that's something that you're interested in, or if not, how you might use it.
If you are planning to partition more than a single table in your Postgres environment, this is the talk you have to see, because if you partition multiple tables, you have only one chance to do it right, and this talk gives you all the information you need to do to build a great environment, which is really fast forever and ever. So, welcome to Partition Your Tables for 20 times better performance.
So, hi, my name is Thomas Vondra. I do work for EDB. I'm a long-term contributor, developer, and also a committer. And I'm here to talk about performance cliffs, which is a performance issue affecting a lot of people that may not be aware of that. I'm going to explain how the performance issue actually happens and why.
I am a senior software engineer in a team which is responsible for internal database as a service platform. And today I want to share with you our findings and experience when adopting and supporting our internal CDC solution based on logical decoding.
Hello everyone, my name is Hans-Jürgen Schönig. I'm the CEO of Cybertech, and hopefully for this year's conference I've prepared some really interesting performance stuff you've never seen before. So if you're seriously interested in performance, check out this talk and learn something that is way beyond just adjusting some Postgres configuration parameters. Have fun.
Hi everybody, I'm Luigi Nardi. I'm the founder and CEO of DBTune. Very excited to be here at Posette. Today we'll be talking about auto-tuning Postgres. So if you are interested in learning about the configuration of your Postgres instance to achieve high performance, this may be the talk for you.
Hi, I'm Karen Jex, Senior Solutions Architect at Crunchy Data, and I'm speaking at Posette about why you don't need a database backup policy. You're probably wondering why, as a DBA of over 20 years, I'd be telling you that you don't need a database backup policy. So hopefully this talk's going to be interesting to anybody who has data that they care about and want to keep safe.
Hello everyone, my name is Kloba. I am Senior Solution Architect at Microsoft, and today I want to present a solution which we created for a tight NATO hackathon to advance drug search and also show how we utilize for this Postgres and the Azure AI extension.
Hello everybody, my name is Federico Campoli. I am a freelance PostgreSQL consultant, and today I will talk about PostgreSQL running on top of ZFS, a powerful file system but with a bad reputation. So if you are a sysadmin or DBA and you are searching for an alternative for performance and scaling up your system, you may be interested in my presentation. Thank you.
Hi everyone, I'm Paolo Melchiorre. I'm the CTO of 20Tab and I'm a member of the Django Software Foundation. I use Django since a long time to do my web project, and today we'll see together how to integrate semantic search using Postgres and pgvector.
All right, so many shining stars that we needed to put our sunglasses, because so much light coming from this live stream for so many great speakers. So we are really looking forward to this. Now that it's only the two of us, I mean, we are not that shiny, so we can remove the sunglasses. So it's all good. This is what we are going to have today. Really nice. I'm super excited, and I'm happy that they put us in this live stream for. All the three were already good, but I mean, this one is the live stream.
Yes, yes, for sure. This is, I mean, I asked to be put on this live stream so that I could watch these videos live and comment in the chat. So yeah,
yes,
it's
exactly.
This is now it's time for our first speaker. This is
Keynote.
Our first keynote, or fourth keynote, but first keynote of the day. It's Thomas Munro. He's a colleague of mine at Microsoft, and he's a Postgres developer and committer. And he's gonna walk us over like a tour of Postgres in his keynote. And he loves skateboarding. That's one thing I know of his like personal life.
Yeah, I met him in a conference here in Europe, and he was carrying his skateboard during the conference. So
yeah, he's always
nice
carrying it around.
Yeah,
he is
and
dedicated that fits his skateboard and his laptop. It's really cool.
And if I got it right, I mean, he lives in New Zealand, where The Lord of the Rings was filmed. So everything falls into pieces. Yeah, I'm a very big fan of that, and then it's good to see that he's coming all the way from there to give us this talk and this conference.
Yeah, let's just get into it and watch this keynote.
Hi, everybody. Thanks for tuning into my talk. My name is Thomas Munro, and I'm going to be talking to you about the Postgres project, or PostgreSQL, where it came from, what sorts of things it does, how it is made today, who makes it, and a bit about how I myself got involved in it and how you might get involved in it if that's something that you're interested in, or if not, how you might use it. All right. So welcome to my walking tour of Postgres. I'm going to start with a really basic question. What is it? A colleague of mine, Jelte, on Twitter, one day sent out this excellent tweet. It was part of a longer discussion. To my non-database friends, I've started explaining Postgres as a really big Excel sheet for that websites can use. I think that's a great starting point for understanding just generally what databases do, database management systems. And I'm going to try and sort of develop from there and explain in more and more technical terms what the project is about. So we can say that it's like a spreadsheet in the sense that it has tables, but the tables are a little bit more structured than an Excel spreadsheet. They have more fixed types and the columns have names and so on, but generally it's the same sort of concept. And there's a whole bunch of things that we call, there's a sort of an idea we call the relational model that allows things in one table to refer to things in other tables in a way that imposes some kind of order and avoids things getting out of sync and data from being corrupted. And then there's a whole lot of engineering that goes into making it possible for that data to be updated in a sane way when there's all kinds of modifications taking place at the same time while queries are being run. And queries are this kind of basic concept in databases where you say things in some kind of query language. We have this language SQL, structured query language, which is used instead of, with a spreadsheet, you might modify something with a GUI, whereas with relational databases like Postgres, you would use queries to insert or update or delete data. And along with insert, update, and delete, you have select, and that's a way to query and ask questions of the system in this kind of language that you have to learn. But actually, mostly it's computer programs that write the queries and not humans, even though the humans can also write them directly. So, for example, we have a couple of tables here, department and employee, and there are ways to write these queries that can join together information from different tables. And if we want to modify that data, we have to run insert, update, or delete statements, as you can see here on this slide. I'm not actually going to go into the details of the SQL language. I'm just going to talk about the more general sort of concept of the relational model and what type of systems use that model and why it's a good idea. So we can say that Postgres is like a whole bunch of these other products. And I was wondering which ones to call out. I went to the dbengines.com survey where they try to track the popularity of different databases. We can see, if you look at the top 10 databases that they track, you've got Oracle, MySQL, Microsoft SQL Server, Postgres, then some other non-relational databases. Let me just highlight the ones that are relational. Out of the top 10, you can see most of them are relational. It's an extremely popular model for dealing with data. Not the only model, but it's a very popular one. So I want to talk a bit about the origin and context of that model, how it comes to be so popular. If we go back to the 1960s, IBM was involved in the Apollo space program, and they had a contract to build some type of information management system, which they called IMS, Information Management System, to keep track of the huge number of parts in the Apollo space program. And that was a hierarchical database system, one of many different kinds of database systems. And a man working at IBM called Edgar Codd came up with this. He saw the difficulty people had with keeping track of data that references other data and duplicates in the information and ways data could become corrupted over time in highly concurrent and busy systems with many people and systems interacting with it. And he came up with this idea. He was a mathematician. He came up with this idea of the relational model, which lets you, it imposes a set of rules so that data remains structured and is maintains its consistency over time. And he published that paper around about 1970. And it wasn't until a little bit longer that IBM produced the first working system. Actually, I think there might have been some earlier experimental systems, but the first system that was widely used was IBM System R. And that used a SQL language. And if you look at old documentation from that system back in the early to mid-70s, it's very familiar. It looks like the modern SQL system. But the relational model didn't require SQL. There were other programming languages, or sorry, I should say query languages that were competitors. Quell was a popular one, and Ingress was a very early and very successful product that used the Quell query language to, and I've met a number of people who use these Quell systems, Ingress systems in telecommunications, like all kinds of big users of early users of computers used Quell. And the team that developed Ingress was Michael Stonebreaker and some others who were at Berkeley, and they later decided to develop a second project called Postgres. Ingress stood for Interactive Graphical Retrieval System, and Postgres was sort of the next one where they wanted to try out a new set of ideas. And Postgres also began with Quell as the query language. So if we look at the relational model paper, we can see that some of the really big ideas, which is worth reading, by the way, and it's very approachable and readable. Some of the big ideas were getting away from dependence on the physical storage of the data. So thinking of things in terms of quite high-level concepts, sets of tuples, the word relation essentially meaning table, and ways of not repeating yourself so that you don't have information stored in multiple places, so that it's not possible for one thing to get out of sync with another. That whole model is, I'm not going to go into in great detail, but it was an extremely influential idea. And here we can see, this is a paper from, I think it's from the 1970s, 1981, showing where a kind of retrospective of the System R system. And it looks very familiar to a modern reader. It's clearly the ancestor of everything that we're doing in relational databases still today, many, many years later. In 1985, Stonebreaker and others working at Berkeley set out to design a new database project. And if you look at this paper from 1985, they listed some of their goals. They wanted, and those goals, you can see the effects of these goals in the modern Postgres project. For example, so 1 and 2 here, they wanted user extensibility for data types and complex objects. And we can see that still today with projects like pgvector, which is really big in the AI space right now. It's possible because of the way, like some of the design choices made back then, and this kind of goal that you should be able to, that complex data types and operations on those and indexes that support those should be possible, even though they're outside of what the original developers of the database system had in mind. And another very famous example is PostGIS, the geographical information system that involves all kinds of custom indexes and data types. And it's very successful in Postgres and is able to be done as an external project, essentially because of this planning. So that was university Postgres in the 1980s. Something else was happening at Berkeley around the same time. In 1986, there was some legal wranglings, and Berkeley University lawyers came up with this BSD license concept. That was some of the earliest software that was released with what we would call an open source license today. Of course, there was an open source spirit before that. People shared things and developed things cooperatively. But in around 1986, that's as Postgres was being born, that software was being developed on BSD operating system computers, also Sun systems, I think. And so the sort of BSD license was sort of a natural thing for them to use. And to this day, we have this license that's BSD-like, and it has enabled Postgres to have a lot of forks, commercial and non-commercial, which is part of the sort of flavor of the Postgres ecosystem. So if we go back to our time chart here, where we can see all these different databases being born in different decades, you can see that Ingress was very early. It came out only slightly after System R. System R later on was replaced by DB2 at IBM. And you can see that Postgres had these sort of two phases. First was the university phase, beginning in the mid-'80s and ending in the early 90s. And at that time, that was a quell system. Then this kind of black hole of in the historical record, because we don't actually have nobody I know has the source control history from the end of the university Postgres time and the beginning of the open source project. But in that window, the system was changed by people from Berkeley to use SQL. And then in 1996, the modern open source system that we use today, and we can trace all of the commits and changes back to 1996. It began as a SQL system. So it's far from the very first of the relational database systems, but it's sort of connected to very early relational database history. Another interesting thing about Postgres is that we actually developed parallel query execution twice. The university project included it. They had access to early computers that had a lot of CPUs at Berkeley, whereas access to that kind of hardware wasn't that common for the people who developed the open source project much later. And in that time window where we sort of lost track of the source control for a couple of years, that functionality was mostly removed because no one had access to the multi-core hardware, or multi-CPU hardware. But much later, a different group of people that I was involved with re-implemented parallel query execution. So I think that's quite an interesting, there are examples where Postgres was really quite groundbreaking and quite early on, a major shift. In the modern project, we can say that it has a huge number of commercial forks and derivatives. And I think the reason for that is that many people who've got an idea about something they want to try, a kind of special source, they don't want to solve all the problems that a relational database has to solve. And they want a ready source of users, or they want, assistant. They want to be able to get things off the ground immediately. They want client libraries to work and so on. And Postgres is a very good place to start, especially because it has a very permissive license. But many of those projects finish up continuing to contribute to the upstream project, and it seems to be pretty healthy at the moment as a result of that. So if we look at the data, we can see there's about 400 to 500 people who are regularly contributing code or reviewing each other's code. And by that, I'm looking at email addresses that are discussing the development of Postgres on the Postgres development mailing lists. We can see that there's over 100 different employers involved for the people that work on that. And they have many different kinds of interests, everything from academics, students, software consultancies or database consultancies, DBAs, people who work on proprietary forks, and of course the managed Postgres providers and cloud vendors. So one thing we can say about Postgres is that it's absolutely not the type of single vendor open source that some other systems represent. There's no one really in charge. It really is cooperation between a lot of equal participants, which I think is pretty special. And there aren't too many projects that you can really say that about, or at least to the same extent. So it consists of about 1.5 million lines of C, which is quite an old language, and it is a little bit difficult in a way that people who want to get involved in Postgres, one of the first challenges is they might need to learn C if they don't know it already, and it's not a language that people learn commonly these days. On the other hand, it's the goal of the system is to produce a high-level language, and sometimes that involves lower-level knowledge. And in fact, a lot of people work at different levels within Postgres, closer or further away from the metal, so to speak. Another thing that's quite interesting about our open source model is that it's entirely done by mailing lists, which is not unique. There are certainly plenty of other projects that are like that. Usually they're ones where dialogue is really important and it's relatively complex, and and it's also obviously correlated with the age of the project. So it's not totally on a mailing list. There is a web application where we track proposals, which you might say is kind of equivalent to a pull request in other systems or other projects. And typically we have about 300 patches or so in consideration. That number keeps going up. There's a gentle increase in the number of people at the moment. That seems to be the case. All right, so I wanted to talk a little bit about how I got involved in Postgres, and I'd been using it for, I don't know, more than a couple of decades, and at one point in my employer at the time was interested in moving from one database vendor to another, and one of the features that was missing from Postgres was if you were doing a queue-like workload and you tried to use row locking to select jobs from a work queue, there was a bit of a scalability problem, at least with this type of design. And that was something that was used in a software product that I worked on. And so, I was determined to try and fix that. And that was my first proposal to the Postgres mailing list, where I just added the skip locked feature. And you can find that in, at the time, it wasn't in Postgres or MySQL, but it was present in all of the proprietary relational databases. And I was determined to fix that. So it began with simply writing an email, right? And just saying, well, here's a problem I'm facing. Here's how I think it should be solved. I've looked at the code and I've figured out that this is the pathway that I think, this is how I think we solve this problem. And it was a huge number of people replied and helped me and said, that's a feature that we want. That's something that I've wanted myself. And I think you've made a mistake here, here, and here. And work through this process of essentially mentoring and development of the feature. And I think it was probably a couple of years between that email and the day when I opened up the Postgres manual and ta-da, there was my feature. At the time, I wasn't working on anything like that in my daily sort of work. So that was sort of a late night hacking activity. And yeah, that was a pretty positive experience that eventually led me to realize that I wanted to get more involved with the project. And I mean, yeah. All right. So one of the things that's great about the Postgres project, and I think probably relational databases generally as a field, is just the sheer number of different specializations that are hiding inside this one project. So I wanted to talk just briefly about some of them. There's the obvious things that are obviously like kind of core database topics, like query planning. How do you make a query planner? And this whole courses and textbooks and things about that. And query execution generally is just such a broad and vague term that it's almost meaningless to put it on a slide. But then there's a whole lot of things that might be less obvious too that are specializations within a database. For example, parsers, compilers, interpreters. In Postgres, we use the LLVM library to do JIT compilation of expressions. That's a whole field of specialization. There's a lot of things to learn about there and to work on. In fact, there's enormous opportunities to use that more within Postgres to make it go faster. There's constant adjustment and revision of basic things like how you should sort. I mean, so I'm seeing new patches come in just this week that show I don't know, I think it was more than 10% speed up on sorting operations by new tricks. People are there's just so many opportunities in there. Then you have other things that I guess might be more in the classic database, obvious database area. Different new types of indexes or access methods constantly being worked on, developed. So many different parts of the system, and I'm not going to go through all the things that I put on the slide here, but just to give an idea, system interfaces, I/O performance, network I/O, so many things to learn about and to work on. Some of the things that I was talking about in this talk, in particular the stuff from the early days, comes from reading this excellent book, Making Databases Work, The Pragmatic Wisdom of Michael Stonebraker. And that's a book that came out to celebrate his Turing Award that he received for his work on his lifetime of work on databases. And that includes quite a large, it includes chapters written by many different people that worked in and around the Ingress and Postgres and other related projects in the early days. There's also a really good history section in the Postgres manual It's called the brief history section. And in there, it's actually got pointers to papers that show a lot of the early decisions and goals of the project. Another thing that's really good with Postgres is the sheer number of conferences at the moment. Regional conferences, online conferences like this one, and kind of global conferences where developers meet up and talk about their work and you know, essentially negotiate how people work together on these things. Of course, the main resource is the Postgres Hackers mailing list, and on there you can find people discussing every aspect of the future of the project. All right, that's the end of my talk. I hope you enjoyed this quick walking tour of Postgres.
That was great. I learned a lot about the origins of Postgres because I wasn't around, or at least I don't think I was even existing maybe at the start.
I was, but it's nice to hear from here, and also sharing that first email that he sent for the skip block. Very interesting stuff.
Yeah.
If people like this presentation, they should say it in the survey. There's the link. If you want to provide feedback for Thomas or for the event, that's the place. Yes, there you have the QR codes.
And as always, we're going to keep mentioning this after every talk. Be sure to join the hallway track in the Posette Conf channel on Discord, because that's where the speaker is and he can answer some questions that you might have. If you want to know, I don't know, some other details about some of the things you just shared, you could go there and ask questions and talk also to the rest of everyone watching the talks. So yeah, be sure to go there.
Yeah, and if you want to know more about Thomas Munro and his story, you can also listen to one of the podcasts, and the Pastus Icon podcast, where he appears also telling us how he started working on Postgres and as a developer in general. So a lot of nice stuff in that chapter. Yeah, absolutely.
Yeah, and be sure to if you want to tweet, or it's not called tweet anymore. If you want to X. If you want to X about this, be sure to use the hashtag PosetteConf. Like, the conf part is important, not just Posette. And with that, on that note, we'll just sort of go to the next talk, because you don't want to hear us talking all day. We're here for the speakers.
But one thing before you go with there, I've been collaborating with Derk and this year, and I really have a lot of fun working with him. He's really creative and a lot of challenges, and I really liked working with him. Now, there is something that he does a lot, which he plays chess a lot. He carries his board everywhere. This is one of the most, but this is the most important piece, a powerful piece in chess. You have to protect the king and then attack the other ones. But I think that Derk, he feels more like identified with this other one, the knight. He's kind of the knight of the chess in Postgres. Have you ever played chess with him, Jelte?
Oh yes, I played chess with him at FOSDEM. I even won once. I definitely think he was better, but I sort of confused him with a weird move, and that made it. That gave me a bit of an advantage. So that's yeah. So no, it's yeah. So it's great. Let's go to the talk. Derk van Veen. I'll pronounce it on like pure Dutch. He's going to give a talk about partitioning tables and how to get lots of performance out of it. Let's go watch.
Welcome to this talk about table partitioning in Postgres. If you are planning to partition more than a single table in your Postgres environment, this is the talk you have to see, because if you partition multiple tables, you have only one chance to do it right, and this talk gives you all the information you need to do to build a great environment, which is really fast forever and ever. So, welcome to partitioning your tables for 20 times better performance. When I talk about partitioning, I always start with this picture. It's from my home, this is the Lego set for my kids. This is how we store the Lego. First, we did the thing I think everybody does. You put all the Lego in one big basket, and then you can play around with the Lego. But the kids didn't play with it. But now we partitioned our Lego, and we partitioned it by color. And as you can see, now it's very easy to find certain pieces. If you want to have a yellow brick, you go to the top drawer and you search for the yellow brick you need. But when you partition things, you have to make choices. There's no optimal solution here. And usually when it's with data, these choices you have to make, they are very strict. But with Lego, you're way more flexible. So if you take a close look to this Lego, you see actually I cheated a little bit. Because in the 5th drawer, there are both orange and red bricks. And in the drawer below, there's the pink and purple. But the 2 drawers below that one both have white bricks. And if you're now searching for a given color of a brick, it's really easy to find this color, right? But there's also a downside. Because if you build something, and then afterwards you take it apart, now you have to put effort in putting the bricks in the correct drawers back. Otherwise it becomes messy and then your system doesn't work again. And at the moment, all the Lego fits in this single set of the single closet thing with drawers. But if I have more and more Lego, I might have to expand this. And when I expand it, maybe I have to move data around again. And of course, with this amount of Lego, it's a trivial decision. But imagine this is a huge amount of data. Then if you want to move terabytes of data around after 10 years because you made some suboptimal decisions, then these decisions can really bite you. So when it comes to partitioning with data, these decisions you make in the early stages, they are really, really important. And basically you have only one try to do them right. And that is what I'm about to talk today. This is me. My name is Derk van Veen. I'm a database specialist at Azure, and I spend a lot of time working with partition tables within Azure because we have a lot of tables and we have a lot of growing data sets, and this data has to be partitioned, otherwise it doesn't work. If I'm not playing around with databases, I like to play with chess pieces. That's why the Green Knight is there as well. So if you meet me at a real-time conference, I always have a chess set with me. You can always play a game of chess with me if you don't want to talk about databases for just a few minutes. But today, we are not talking about chess. We are talking about partitioning. And first, we have to master to partition a single table. If you don't know how to partition a single table, it's hard to partition more than a single table. But I already partitioned a lot of tables, and I can already tell you I made some design flaws. And I will tell you what these flaws are and what the problem is. And then if we know what the problem is, I also can tell you what would have been the best setup we could have chosen years and years ago. But today, I will just do it right at the first try. So, mastering partitioning. What does it mean? Well, like all things we do in database, with databases, we do things for good performance or to make my life easier. For me, that's also good. But usually, we want to make things faster. But when it comes to partitioning, you also want to do maintenance. And maintenance is much easier for partitions than it is for a big table. If you have a multi-terabyte table, doing anything with it is pretty hard. But if you have a lot of partitions and every partition is maybe hundreds of gigabytes, doing something with this hundreds of gigabytes, it's much easier because it's so much smaller. And you can even optimize single partitions because maybe this single partition contains very old data. So you can make special decisions for this older data, and you don't have to do the same decisions for the relatively hot data. And also vacuum is really important when it comes to partitioning. Vacuum is a really expensive process, and if you can make this process easier, it's always good. And vacuum a small partition is much easier than vacuum a very large table. So with respect to vacuum, partitioning also really helps. And then if you want to do something with data tiering, if you want to do data tiering within a single table, but you want to do it in a transparent way to the application, partitioning is a must-have. You can't get this done without partitioning. So if you want to have any chance to do data tiering today, tomorrow, next year, in 10 years, partitioning is definitely the way to go. And then there's a 32 terabyte table limit. This 32 terabytes is a lot of data, but we are collecting more and more data all the time. So within the next coming years, I think more and more companies will collect data, and they will hit this limit if they are not careful. So there's just no way to store more than 32 terabytes in a single table. So if you want to store more data, I know it's a lot, but if you want to store more than it, you have to do partitioning. And then the final one, and this is the most important one for today, partition pruning. Partition pruning happens in multiple ways. The first one is, let's say you're collecting PII data, personally identifiable information, which is basically information which you can use to target a single person. This information can't be stored forever and ever. So depending on where you collect this data, you have to get rid of it after 5 or 7, or for some countries, even 10 years. But then if you partition your data on a date, and then when this date is like 5 years or 7 years in the past, you can immediately drop the entire partition, which is way less expensive than going through your entire table and you have to delete all these rows. So when it comes to data, when it comes to partitioning, this pruning is really important. But also when you're selecting data, pruning is important. Pruning, when you're selecting data, means like you target a single partition or maybe just 2 partitions, while maybe you have hundreds of partitions. But it's a really important thing to be able to do, because if you're not touching data, it's just faster. And this is mainly what I will be talking about today. So let's take a look at a single partitioned table. In this case, it's the test partition table. It's a really small table, but it shows you what you have to think about when it comes to partitioning. This table has a primary key, which is a ID, and this table is also partitioned on ID. So ID is the partitioning key. The partitioning key has to be involved in the primary key, and there's a very important reason for this. All the partitions are individual tables, and all these individual tables have their own indexes on it, but there's no such thing as a global index over all partitions. So if you want to enforce a primary key, there's no other way than include the partitioning key into your primary key. It's the only way Postgres can maintain your primary key. So when it comes to deciding on what column do you partition your table, this is a very big choice you're making. Sometimes you need some data in a partition, but you partitioned, in this case, we partitioned on ID. But sometimes you need data based on the date. How can you do this? Well, you can add check constraints on your partitions. So in this case, I add a check constraint saying, hey, my data is between the 1st of January and the 1st of April for my first partition. So now the optimizer knows, like, if I'm looking for data in February, I know I can target this single partition. So check constraints are also a good way to prune partitioning, to prune partitions. And there's the default partition. And the default partition I have a mixed feeling about. In general, I would say don't use default partitions. Default partitions are the root of all evil when it comes to partitioning. But sometimes, in very rare circumstances, they are the perfect solution for a tough partitioning problem. If you want to know more about it, I have an article about it. It's too much for today. But if you want to take something away from today, just don't use default partitions unless you have a very, very good reason for it. So when it comes to partitioning, there are basically 2 ways in Postgres to do it. This is inheritance-based partitioning. Inheritance-based partitioning means you inherit properties from one or multiple tables. And it's not as how we do it with parents and children, like you inherit something from your dad and something from your mom, and then you'll have your personal mix. No, this is table partitioning. You inherit all the properties from all of your parents. When it comes to partitioning, inheritance-based partitioning is very flexible, but it also means it's not transparent to the application. So if you're inserting data into a inheritance-based partition, you have to specify, I want to have it in this partition. Selecting is transparent to the application, but inserting data is not. On the other hand, we have inheritance-based partitioning. We have native partitioning, Native partitioning is more strict, but the good thing is you can do pruning very easily with native partitions. You can do pruning both at planning time of your query and execution time of your query. With inheritance-based partitioning, you can only do pruning at planning time. So that's a big difference between the two partitioning strategies. Also, when you're doing native partitioning, you can only use hash partitioning, list partitioning, or range-based partitioning. So that's also a limitation. But in return, you get a completely transparent table to the application. So when you're using native partitions, the application will not be able to tell whether this is a normal table or this is a partition table. So if you have to decide what type of partitioning you would like to do, I would recommend just always go with native partitioning. Then you also have to think about indexes and foreign keys. They just work a little bit different for partition tables, and you just have to invest a little bit of time if you want to do partitioning to look at your indexes and your foreign keys. How do you manage them? How do you create them? How do you drop them? It's just an important thing. And the same is with locking. Within Adyen, we manage transactions, financial transactions from all over the world. So our environment is never down. So if we want to do maintenance and we need a very heavy lock on a table, that's a problem. Then we can't do work on this table. So we optimized everything we do with partitions with respect to locking. So if you want to create partitions with minimal locking, add partitions, drop partitions, add indexes, all this kind of stuff, we have an entire function library about this, and you can just find it on GitHub. It's just a nice way to do it. Please use it. It's free to use. And if you have improvements, please let me know. All this information I combined this into a guide for developers because I like partitioning. I like to think about strategies, how to do it, understand all the internals, but I don't want to partition all the tables. We almost have 1,000 developers, and I don't want to help 1,000 developers to partition their tables. So I created a guide with the do's and don'ts, and now the developers are good to go. It's kind of freedom within a framework, and yeah, they can do their thing, and everybody's happy. They are not depending on me, and I don't have to do boring things all the time. So yeah, job done. Well, not exactly job done. I would like to share information with the community, with all of you, so you can do your partitioning as well, and do it in a better way than I did it. So we created the slide says a blog, but it's more like a list of extensive articles about partitioning. This is a link to the repository with all the functions you can use, and we lived happily ever after because everything is perfectly done, it's arranged, and this is a good moment. I did all the work, the function library is in place, the developers can do their work, and everything is fine. So I could spend my time on other projects. But then, on the live environment, we had some minor issues, and I actually had to take a look in them. So I did partition my individual tables correctly, and everybody can partition his own or his or her partition tables now. But when it comes to the live environment, there seems to be some problems. There are some design flaws in my approach. And these design flaws basically have to do with the optimizer and prepared statements. When you send a prepared statement to the Postgres optimizer, the first 5 times, Postgres will create 2 plans. One custom plan, which is how do you execute this individual query exactly? The generic plan is how do you execute this query, but I only give you the values I want later. So in my example table where I have a test partition table with an ID, the custom plan is how would I retrieve ID number 5? The generic plan would be how do I retrieve for any number? And sometimes the optimizer decides to go for custom plans. Sometimes the optimizer goes for generic plans. The optimizer goes for generic plans if they are not much more expensive than the custom plans. Why is this? Well, creating a plan is very expensive. It's a lot of calculation. You have to calculate the optimal join order. You have to take a look at all the tables involved. Is the query syntax correct? All this work you can skip if you're reusing the same plan over and over. So that's a good thing to do. So let's say the custom plan executes in 1 millisecond and the generic plan executes in 6 milliseconds. This is a big difference. It's a factor of 6. So the optimizer will say, like, I will go with custom plans. But especially with partitioning, creating this plan might be very expensive. So I go for the custom plans because it's 6 times more, or 6 times less expensive than the generic plan. But now, as a bonus, I have to spend 10 milliseconds executing or creating all the plans all the time. So instead of winning 5 milliseconds, I'm actually losing 5 milliseconds per execution. And the only way to fix this is at session level you can set to enforce generic plans for a specific query. And this happens if this happens once, you think like, yeah, this is okay, this is an exception, but this tend to happen more and more. And then it's just not fun anymore. It starts to look like work. And then last year we had a problem with this one. We had a problem with fast path logs. Fast path logs is something in Postgres. The first 16 objects within your session you want to log, they are very fast. This is your fast path. If you want to log 17 objects or more, then you need to go to the log manager, and then this log manager will manage all the other logs for you. Let's say I'm just joining 2 ordinary tables with each other. Then I probably need to log 4 objects. I need to log my table, I need to log my index, I need to log my other table, and I need to log my other index. So in total, that's 4 objects I need to log. But now, let's assume I need to log 2 partition tables. And maybe my one table has 10 partitions and the other table has 20 partitions. Now, suddenly, I need to log 10 partitions. I need to log 10 indexes on this partition. And on the other table, I need to log 20 tables and 20 indexes. So this is already a total of 60 logs, and I'm only joining 2 tables. So I need a lot of logs managed by the log manager, and then you can have very nasty problems on getting a log on the log manager. You can Google this. GitLab struggled with this problem. There's a lot of it about it, but the solution I'm showing you today also circumvents this problem. I really like this quote. It applies to real life, but it also applies to databases. The fastest way to do something is just don't do it. If you're not doing it, it doesn't take any time, right? So when it comes to partitions, your data is nicely partitioned, right? Now, if I target a single table, I only spend resources on reading from this single partition. But if I target a lot of partitions, I have to check a lot of partitions. So maybe I have to check on every partition, I have to check a single index. But only checking this index and finding out I don't need it, if I have 20 partitions, this is already a lot of work, and I want to skip work. And this is even more important when you do data tiering. I don't want to pull some slow disk to find out there's no data I need. So when you want to avoid work, partition pruning at query time, at execution time, this is so important. This is the holy grail when it comes to partition performance. Because this is our current situation. And only by looking at the slide, you can already see this is kind of messy. We made optimal choices for every single table, but now looking at the overall picture, this is just a little bit messy. And to make things worse, the ledger tables are partitions based on the inheritance-based strategy, because we did this many years ago. But all the other tables, they are done based on native partitioning. And on the left side, the partitions are done, the partitioning key is transaction ID. But the ledgers, they don't have a transaction ID because we normalized using the third normal form. So there's the ledgers, they have a ledger ID. So now what happens if I query these tables? Well, you can already guess. It's within this mess, if I join this all together, there's no way for the optimizer to get optimal performance in this setting. So what happens if I query this? Let's say I just need a row from a single partition. Now, if I want to join transaction stuff, I actually need 2 partitions. And then when I join payment, I need more partitions. And then when I go from something which is partitioned on transactions, when I go to ledgers, it becomes really messy. I I draw already a lot of green arrows, but in reality, I actually need more green arrows. So yeah, this is just not very fast. So we made a lot of good decisions. We made good decisions to partition individual tables, but the overall picture has become very messy. And unless we do something about this overall mess, our queries will not be optimal performing. So how do we get back to the green scale? How can we get this fast performing queries? Well, I need a target setup which is just better than this messy environment we created. Well, we already know the drill. We need better pruning. How do we get better pruning? We have to use native partitioning. So that's just where we started. So the first improvement was basically very easy. We take all the inheritance-based partition tables and we just convert them to natively partitioned tables. And for a partition table, this is relatively easy. You just detach all the children from the parents and then you attach them to a new parent, but this time you do it in a way so they are natively partitioned. It takes some tricks, but it's easy to do. So voila, there I have my natively partitioned ledger tables, and let's test the performance. So I target my transaction, and then, yeah, well, it's still not performing very well. I still don't have a way to target specific ledger tables. So yeah, I still have a lot of green arrows, and actually performance has become worse than it was. So after trying it out, we reverted or changed very quickly. Because the problem is these ledgers. I don't have a way to easily connect a transaction to a ledger, and this is the problem I actually have to resolve. So back to the drawing boards, back to the whiteboard, getting all the people in the room, and we said, like, if we could redesign this entire system, how would we do it? What would be the approach we would take? In the middle of our environment is basically a transaction. We process financial transactions. That's our core business. So the transactions should be in the middle of everything. But if you're working in a different company, you should have a leading figure as well. I've been working at an insurance company. And for insurance companies, the leading figure is something like a policy or an insurance object. This could be in the middle of everything. And then when you know what your leading figure is, you can partition everything around this leading figure. And then when you do that, your environment starts to look like this. And you can already see it, right? It's so much cleaner, it's nicely ordered. And also for the optimizer, this environment is so much easier to handle. So this is definitely the way to go. And we partitioned everything on transaction IDs. But, well, aren't the ledger tables partitioned on ledger IDs? Yes. So we are converting these tables. We have to get rid of associative tables which were connecting the transactions and the ledgers on one hand side. But now we are building it in this way, and it's hard to express in words, but this is so cool if you can see how the optimizer is making this optimal decisions. Because if I target now a single table, I immediately know what ledgers I need. I immediately know all the ledger lines I need. I know the transaction steps I need. I know the payments I need. Everything is just perfectly aligned, and the optimizer can make these decisions so easily, and partition pruning becomes so efficient. The title of this talk is to make your queries 20 times faster, but some of our queries in this new setup, they are actually 50 times faster, and under load, sometimes they are even 70 times faster. So for me, this was really exciting to see, and it's such a cool project to work on. So if you want to partition more than a single table, you don't only have to think about how do I partition a single table, but you also have to think about your entire environment. How can I partition in such a way that my entire environment is built around this leading figure? And these decisions might seem far away for you, but they actually are not. And Lego is very easy to get this from one drawer and put it in another drawer. But if you collect data for many years in a row, moving this data around like we have to do right now, it's a lot of work and it takes a lot of time and a lot of effort. So please, if you partition more than one table, just think about it. How do you partition, and how do I create a leading figure? How can I create partition boundaries which are equal for all of my tables? Which means you have to look at what is your biggest table, because that will be the leading size for your partition. You want to have one partition of a terabyte from one table. So try to find out what might your biggest partition be. Aim for somewhere between 100 and 200 gigabytes, and then figure out what the partition boundary should be. And then you have this blazing fast environment based on your partitions. Thank you very much.
All right, very good explained by Derk. I really like the diagrams that he uses and all the way that he goes from one part to the other in a coherent path. So he's a very good speaker, I would say. And actually, if you want to know more about how he prepares for presentations and everything, you can check podcasts where he was invited to share his knowledge and his experience about creating content. So probably Claire somewhere there is going to think like, yes, I need to put the link about this podcast where Derk was invited. So thank you very much, Derk, for that. Now, the next speaker that we are going to have, I mean, I was showing you chess pieces, but then I also have this here, which is a very nice elephant, which probably every speaker has its own place. It is one of the things that we love from the Postgres community. Now, if you have all the stuff like this, you can also share that with the hashtag PostgresConf, and then also don't forget that you get other type of swag for this conference. Now, our next speaker, which is going to be Thomas Vondra. He is one of the, how I say, the herders of Slonic, the large one, when it comes in the conferences, inside in-person conferences. He's actually one of the person who can bring it because he have one of those at his place. And he's a long-term committer of Postgres. Yeah, he's been contributing to code. He knows a lot about the internals of Postgres, and he's going to be also in Discord answering questions. If you want to ask questions to Thomas, he will be there. And he's also one of the organizers of P2D2, the Prague Postgres Developers Days, a really nice event. And I mean, he's definitely one of the persons that I like to see the most because of his knowledge. So anything else you want to add, Jelte, over Thomas?
Yeah, I think Thomas, one of the things I know about him is that he's very good at visualizing performance benchmarks. So I'm very curious how he's going to visualize these performance cliffs. But I've watched one of his talks and I've seen some of his emails, and there's always really clear graphs with lots of information, but somehow still shown in such a way that you can make some sense out of it. So he's exceptionally good at that, because it's really hard sometimes if you have lots of benchmarks with lots of variables to still show sort of what you want to show. And he's quite good at that.
Yeah, I mean, and the reason that he can do that is because of his knowledge he has. And this is one of the reasons why he's one of my favorite speakers in the Postgres area. So without more introduction, please let's welcome Thomas Vondra, and his talk about performance cliff.
So, hi, my name is Thomas Vondra. I do work for EDB. I'm a long-term contributor, developer, and also a committer. And I'm here to talk about performance cliffs, which is a performance issue affecting a lot of people that may not be aware of that. I'm going to explain how the performance issue actually happens and why. I'm also going to mention a couple ways to maybe reduce the impact of the issue, and maybe present a couple ideas for future development and how to improve that in the future. Right. So, as I mentioned, I work for EDB, and the quick agenda for this talk is brief explanation of what the performance cliff issue is about. It's actually a pretty common issue, but it's somewhat hidden. It's not very obvious, or may not be very obvious, and it's kind of inherent to all cost-based planning, right? So kind of all databases that do planning based on cost estimation are affected by that. I will explain why it happens and then give a couple suggestions for improvements. So first of all, like, what actually is a performance cliff? There are probably different ways to define that. I say that performance cliff is a sudden, like a step change in performance. So sudden means not proportional to inputs, right? So for example, if you consider a query, as for example on the slide, which may return 1,000 rows, and it takes only like 1,000 seconds. What if, how long should it take actually to return 1,001 rows, right? I mean, like, if it takes roughly the same amount of time, because it's like less than 1% of difference in the cardinality of the result, that's probably okay, right? But maybe it will take 10 seconds, right? Which is like sudden change, unexpected, based on the change in the parameters. So, and that's what I call a performance, right? Step change in performance. So to explain how the performance cliff can actually happen, I need to kind of like explain how databases do planning based on cost. A cost is just an approximation or like some sort of number that explains how many resources or how much resources will the query need to execute. And by resources, we mean usually like CPU and I/O. And the whole idea of cost-based planning is based on the assumption that if a query needs more resources, like more random I/O, for example, that means higher cost, and that will take longer to execute, right? So the assumption about cost is that it's monotonic and continuous, right? So it changes like gradually, that's the continuous thing, and that it's monotonic, which means that the more data you need to process for a query, the higher the cost, and also monotonic with respect to duration of the query. So if you have a higher cost, it will mean that the query takes longer, right? And we kind of, for the purpose of this talk, I will assume that the estimates, the cardinality estimates are correct, right? I mean, there is a whole class of performance issues about incorrect estimates. I'm not going to talk about that at all. I'm going to talk about issues where we actually know how much data are going to process within some reasonable margin of error, but then do like mistakes during planning later. So to visualize how the cost actually behaves, you can do a very simple thing. I have a query here, and I change the input parameters of the query slightly, right? I know what fraction of the rows will actually match, and that's determined by the condition of the query. And then I can, for each query, measure two things. First is the cost, which is in the first line of the execution plan. So in this case, it's about 24,091. That's the cost estimate for the query. And then we also, if you run the query, you can actually get the timing of the query, right? So in this case, it's about 72 milliseconds. And if you do this for a range of parameters for different fractions of the table, different conditions essentially, which in this case is 1%, but you can change the parameters to get like different results, you will get a table which is shown on the slide. Obviously for your query, the conditions or the values will be different, right? But you can take the table and you can actually visualize that as a chart, right? So in this chart, on the horizontal axis, on X, that's the selectivity, like the fraction of the table that matches the condition, right? So it's between 0 and 100% roughly. And then the blue line is the cost, which is estimated by the database, like estimate of how much resources will be needed to execute the query, and then also the duration, which is the actual time that took to execute the query, right? And you can see that it's more or less monotonic. There's small calculation issue for the cost, close to like 0% selectivity. But other than that, it's very continuous, and it's also correlated to the duration. It's nonlinear dependency though, so it's not very easy to actually calculate the estimated time from the cost, right? So that doesn't actually work very well. So this is what the database actually uses to pick the cheapest plan, right? And that's a bit weird though, right? Because I started this by defining the performance cliff as a discontinuity, like a sudden step change in the query plan, right? And the chart that I just showed is actually perfectly continuous and mostly monotonic, right? So where could we actually get like discontinuities, like step changes in this? And there are like two basic ways how we can actually get that. The first one is related to things decided at the runtime, right? So those are like decisions when if you process just a little bit more data, like one more row, it flips some algorithm or something to slightly different behavior, and that can actually change the performance. The other problem that we have, and I'm going to talk about that later, is having to deal with multiple different paths, different execution plans, right? The chart that I showed is just for a single type of scan of a table, but you usually have like many different ways to run the query, and the database needs actually to change between the plans for different selectivities, right? So first, let's talk about the runtime decisions. And I'm going to illustrate that by a very simple example. Imagine you have a query which is simple sequential scan from a table. There are no indexes on the table. The table has about a gigabyte of data in it. And you do select on that with a condition which is an in condition, which means the column needs to be one of the values listed in the list, right? And I'm going to show the timings and everything using a table which has some random data in it, right? The only thing here is that it's about 10 million rows, and all the strings have fairly long prefix, which is just the character A, right? So if you do this, you can try that after the talk. You should get a table which is about 1 gigabyte of data. And now let's run a query. And the query is very simple. It just has like a list with 9 rows, 9 values. And if you try this, it runs in about a second on my machine, right? Which is fine. That's like a sequential scan of 1 gigabyte of data on like a laptop or something is perfectly reasonable. So nothing wrong with that. Now let's remove one of the values. So we will only have a condition with 9 values. And what would we expect? I mean, like we are going to evaluate fewer conditions essentially. And other than that, we will scan the whole table again, right? Still sequential scan. So we probably expect that to take a little bit less time, right? Maybe 900 milliseconds or something like that. But if you try that, it will actually run in 2 seconds. Like it's actually taking twice as much time as the first query. So that's weird, right? I mean, like, why would this happen? And the reason is very simple. We realize that the list can be quite long, and instead of like doing a linear search through a long list, what we do is we build a hash table, right? And then we actually for the list in the in condition, and then instead of searching through the list and checking all the values, we just do a lookup in the hash table. Perfectly reasonable. However, this is not efficient if the list is very short, right? And by short, I mean fewer than 9 values, which is why I used 9 values in the first query, because that's the case when we actually start using a hash table. So by removing one value, I actually forced the database to use a linear search, which is not very efficient in this case. So, and that's why it took so long. The problem with this is obviously it's a decision that is hard-coded. The threshold is not perfect for all possible data types, all possible cases. And it's impossible for the database to know this in advance, right? So there's not much we can do to improve that. Maybe there is a way to make this more adaptive to kind of like respond to the actual execution, but that's not implemented, right? So you can actually run into this. So there are other runtime decisions. This was just a very short example, right? So for example, when you are doing anything that can start spilling data to disk, like a sort or hash join or hash aggregate, for example, that can actually happen unpredictably, right? The database may not actually consider this during the planning and then realize actually it needs a little bit more data and starts spilling data to disk, which can be quite expensive, of course, right? Another example of runtime decisions is just-in-time compilation, which is decided during planning, but we also don't have a very good heuristics about when it's going to be beneficial and so on. So it can actually hurt the individual queries. And there is an ongoing effort, multiple patches currently in development that should help with this. So now about the other problem, which is about multiple paths. So for this, I'm going to show a different example. We have a table which has about 100 million rows, and it's mostly random, except that it's random for the same value being stored on a single page, right? So we can fit 59 rows on a single page in this case for this table. So we have like 59 repetitions of the same value, which means we are going to select random pages from the table. And with 100 million rows, it's about 13 gigabytes of data, right? And I'm going to use about 10,000 different distinct values, which allows us actually to read a well-known or deterministic fraction of the table depending on the conditions, right? So this is the same chart as before for cost of the queries, using 3 different scan methods that are implemented in Postgres, which is the regular sequential scan. Then we have the index scan, and we also have a bitmap scan, right? Bitmap index scan. And again, on the horizontal axis is the selectivity of the condition, which means like which fraction of the table are we actually reading, And then on the y-axis is the cost, right? And I'm just going to point that both those axes are log scale in this case. That doesn't really matter, but the important thing here is that the costs actually do cross over at about 1% selectivity, right? Until that point, the index scan and bitmap scan are like the cheapest way to execute the query. And from about 1%, because of the randomness and so on, we actually switch to the sequential scan, right? From that point, it's easier to just read the whole table than using indexes. Well, or at least the database believes that, because if you do the same chart for the actual duration of the query, you will get a very different chart, where the sequential scan only becomes the cheapest one, actual fastest query execution, at about 27% selectivity, right? So just to make it more obvious, I left there the 1% from the cost chart, and you can see that there's about like 27% difference between what the database thinks is the cheapest execution and what is the actual cheapest execution, right? And that's a problem, because this means that if you do a query that only selects about like roughly 1% of the data, 1.27%, that runs in about half a second, right? 400 milliseconds is what I got. But if you increase the selectivity of the query by just a very tiny bit, like the smallest fraction that I could in this case, and it's 1.28% essentially, then it suddenly runs in 10 seconds, which is 20 times longer. And that's again the performance cliff that I was talking about. And this happens, as you can see from the query, that because the database switched from a bitmap scan to a sequential scan, right? It made the wrong query planning decision. So this is why the database has problems with performance cliffs when using cost-based planning. So what are the ways to actually mitigate this? So first of all, it's really hard, right? It's really hard because it's based on costing, which is an approximation. It's a very simplified model of the data with incomplete statistics that do not have all the details, right? Which inherently means that there is imperfection. And there is a very well-known quote from Goetz Greffe, which means choice is confusion, right? Once you give the database multiple choices, it will inevitably do some incorrect choices. There's no way around it. And it's not limited just to Postgres, right? Kind of all cost-based databases, or like databases using cost-based planning, will have the same problem. So what can you do actually to mitigate this? Well, for some cases, you can actually just make the cliff smaller. You can either ensure that the flip, like the on-off switch of the runtime decision doesn't actually happen. You can, for example, increase the workmem so that you never need to spill to disk. Or you can actually, if the flip happens, you can kind of like reduce the impact of it. For example, you can use faster ephemeral storage to, if you need to spill to disk, is actually fast, right? So that's one way to do to improve the situation. For the cost-based performance cliffs, what you can do, well, the only thing you can do at the moment is tune the cost parameters. You can increase the random page cost or reduce the random page cost, for example, and essentially what you are trying to achieve is you are trying to align the crossover points between the different, between the cost and the duration charts. So in this case, you would try to increase the cost, the crossover from like 1% way closer to 27%, right? Which is the actual point where the execution flips to sequential scan, or should switch to sequential scan. It doesn't really matter. It's a lost cause to try to optimize and fine-tune the parameters too much, because the ideal value is probably different for different queries. It just, the flip needs to happen close enough to the actual point. And there are a couple ideas for future development, and some of them are more like research. The first one is adaptive execution. Essentially, instead of relying on the a priori information, like the statistics and so on, too much, we can assume that in some cases it will be wrong, right? And then try to adapt to that during execution, right? So, for example, instead of picking a single way to scan a table, we can kind of like move from index scan to sequential scan, for example, right? And that's the idea behind a smooth scan, which is one of the research papers that I would like to mention later. The good thing is that this is quite difficult, of course, but the good thing is that it would also help not just with these performance cliffs, but it would also help with the cases where we make planning mistakes because of estimating the selectivities incorrectly, right? And it's essentially moving from performance issues into like more robust execution model. And as I mentioned, I do have a couple links to interesting papers, and I'm going to briefly explain what these do. The first one is the profile of Mr. Gefe, one of the people working on robustness in database execution, and he also said that the choice is confusion, right? The two other links on this slide are interesting research papers doing adaptive execution for different types or different operations in the database. The first one is for the scan nodes, so essentially replacing sequential scan, indexing, and so on with a more generic and adaptive access path. And the last paper does something similar for the join algorithm, right? And on my last slide, I do have a couple links to papers or reports from a seminar, which is exactly about robustness in databases, not just about execution, but about other aspects of robustness. And I think I'm not going to go over the details, of course, but these are, I think, wonderful sources of inspiration, like a starting point if you are interested in this topic. So there is a very nice overview of the problem, and usually links to other research papers that are talking about the same topic. And I think that's all from me for today. And I think I'm ready to take some questions.
Thank you, Boris. Sorry, not. Thank you, Thomas. Too many names.
A lot of questions going on
A
the
lot of
Discord
questions.
already.
Yes.
So
Be
yeah,
sure
very good
to.
discussion.
He said he wanted to answer questions. He's definitely answering questions.
Yes.
So, and be sure if you liked this talk or you didn't, or you couldn't read one of the slides or whatever, and make sure to fill out the talk survey. It's how we grow as speakers and also the event survey, how we grow as sort of event organizers. So yeah, be sure to do that. And please let us know in the chat if you did, just so we know that people are listening to us and we're not just talking into the void over here. And yeah, so the chat on the Discord. Be sure to go there. Thomas is there and he's answering all the questions. Let's if you've been enjoying these talks so far, and after all these talks you're like, I want to see some more. I'm not done. I these hours of Postgres, I want some more hours of Postgres stuff. We have 3 other live streams that we already showed in the past few days, and you can watch them back, and we will show like a little trailer of the speakers of those live streams. One of them apparently in this one is me, so you'll see my face again soon.
Hi everybody, my name is Charles Thurston. I'm the Director of Product Management for Postgres at Microsoft. In my talk, in 25 minutes or less, I'm going to try and cover a variety of things that Microsoft is doing in Postgres, both our commitments to the open source aspects of Postgres and also what we're doing in the cloud.
Today, I will be talking about Postgres parameters. The title of my talk is Tuning Postgres Parameters versus Tuning Log Queries.
And I'm going to talk to you about connection poolers and their support for prepared statements. One of those connection poolers being pgbouncer.
Hi, I'm Paul, the CEO and co-founder of Supabase. Today I'm going to cover everything that you need to know about Postgres row-level security. I'll cover how to use Postgres row-level security, why you might want to use it, and some neat performance tricks.
And I'm going to talk about open source Postgres and how code gets into the Postgres codebase. And if you wanted to put a patch in, the process of submitting patches.
I'm currently leading engineering team here at Ikigai, and I want to share our story because it will give you a lot of insights if you're trying to build and develop an end-to-end AI platform using complex data types and complex AI workload.
And my talk today is called SaaS on Rails on Postgres. It's all about building multi-tenant SaaS applications and the capabilities that we have to scale up and scale out with things like Active Record, horizontal sharding, and Citus.
This session would be really helpful for the customers who are planning to migrate their on-premises workloads, especially Postgres workloads, into Azure, as well as our single server customers who are planning to migrate from single server to flexible server.
Welcome to Scaling the Wall of Text, Best Practices for Logging in PostgreSQL. This talk is for people who are new to Postgres, but also for those who want to improve their experience administering Postgres databases.
This talk is about how you could make your inserts faster, and any PostgreSQL developer who is dealing with data uploads, this is the best talk for them to go through.
Good day, everyone. I'm David Wheeler, creator of PGXN and principal architect at Tembo. Today, I'd like to talk about the state of the Postgres extension ecosystem. Its past, its present, and the future.
Very nice. So that was the presentations of all the things that you can see for the live stream 1. But continuing with the live stream 4, which is today, I mean, if we look about the history of programming, the first person that comes to mind is Ada Lovelace, which is the first programmer, a female character. And we have here with Polina one example of how much coding can be produced in such a young person. She has, if you look at the interview, a very nice background of programming in Greenplum. And Jelte, I mean, you are one of the main maintainers of one of the most popular stuff, pgbouncer, but she is also one of the coders of one of the other tools that is being used for high availability in Postgres, for Patroni. So very impressive.
Yeah, I actually looked at the Patroni source code a while back, a bit closer, because I did it at the start. But one of my colleagues, Alexander, who worked with Polina at Zalando before, he added site support to Patroni that Polina reviewed, and I sort of reviewed the Citus parts of. So yeah, it was sort of great, sort of working with her over the messages on the PR. I guess that was super fun.
Very interesting person. So I checked the interview, and she also has some interesting hobbies as well. She listens to true crime podcast. But of course, today she's not going to be talking about that. She's going to be talking about logical decoding and all the stuff with the change data capture, which is growing in popularity because of combination of different databases and how the logical decoding can help on that. So we are going to hear now everything about that from Polina Bungina.
So, hello, my name is Polina Bungina. I work at Zalando, which is a European e-commerce platform. I am a senior software engineer in a team which is responsible for internal database as a service platform. And today I want to share with you our findings and experience when adopting and supporting our internal CDC solution based on logical decoding. So, as I said, today we will look into the logical decoding in PostgreSQL and actually the hazards behind it. And the plan for today is just to quickly look into what CDC is, what are the approaches for PostgreSQL, and then go directly to the logical decoding, the concepts behind it, and the hazards which it may bring to you. So first, CDC is essentially change data capture. It's a set of design patterns which used to track changes that occur in your data, when and what kind of changes, and then notify the external systems about those, which basically helps you to maintain consistency across all of those systems. For Postgres, we mainly have three approaches to do that. First is to run queries against dedicated timestamp columns, such as created at or updated at. Then you can use old good triggers just to create them for the events you want to be notified about. And then the maybe most modern and advanced solution is to use logical decoding, which I want to talk about today. So logical decoding is effectively a process of extracting all changes persisted to write-ahead log back to the format which is human readable or the application friendly and can be further used without knowing the internal state or structure of the database. And my idea, what I want to tell you today is that even though this approach is very advanced and it actually enables a lot of new use cases for you, it can be dangerous. And it's rather complex. It requires you to understand all the implementation details, maybe not all, but the most important that can be dangerous. And it's not only about database administrators, but also about the end users. And to cover those, I would like to split my talk into three parts, talking about the three main components, so to say, of the logical decoding. And we will start with the decoding process itself. What is important to know is that PostgreSQL cluster has a single write-ahead log. It's for everything, not split it per database or per table. And the second part, a bit more tricky, but you need to remember that by default, all transactions are sent to the consumer only on commit. Of course, you may say that since PostgreSQL 14, there's a streaming of in-progress transactions mode, but by default, it's only implemented if your consumer is another PostgreSQL instance. But of course, for other implementations, for your end applications, you would need to implement it yourself. And it's rather questionable if you want to implement it and store data before they are actually committed, before this data is actually committed on your application side, or it's better to keep it on the database side. This way, I will concentrate on the default behavior. And to better understand why it's dangerous, I would like to quickly look into the process. And for every connection, for logical decoding, there's a separate wall sender process point, which reads sequentially all the wall records and decode each of those and store those in a specific buffer, basically queues it in a reorder buffer. When a commit message is reached and decoded, then the associated transaction starts to be replayed. And for every record, there's a specific callback called, which is basically the place where the customization takes place. And for example, output plugins, which implement this customization, can transform your data into any format you want it to be. And also what is important on this step, there's a filtering taking place. The so-called publication define if you need to stream this data further or it can be filtered out. And why it is so important to know that is, imagine you have transaction number 1, which is opened, and then suddenly another transaction comes, and there is this transaction is very write intensive. So, for example, it inserts a lot of data, and then it commits. This way, it doesn't matter how quickly you commit the first transaction. Your receiver will first receive all the changes from the second transaction, which needs to be decoded, replayed, filtered, and only after that, the changes from your first transaction will be received. As I said, there is a reorder buffer, and it's stored in memory, but of course, memory is not endless, and there's a limit after reaching which all the decoded changes not yet committed will be spilled to disk to a specific directory. More insights on the process can be found in the pgstat replication slots system view. There you can find cumulative information about how much was decoded in general, or what is more important, how much was spilled. And this is probably, and I think, yeah, it's worth monitoring. And this is available since Postgres 14. Another important nuance worth knowing is that for every decoding process, there's a separate wall sender response, consequently a separate decoding process happening. You would allocate every time this logical decoding work mem amount of memory and spill decoded data for each process, and each of them reads the same wall record stream, so does the same work. And another thing worth understanding is that it's actually very difficult to scale this by just scaling your instance vertically, because each decoding process will only use a single CPU core. And as an example, how to easily get trapped by those nuances, those hazards, is our favorite online vacuum full and cluster tool called pgvector. And actually its initial step is to copy all the data from the target table to a so-called temporary table, which is of course a very write-intensive operation, and it's done in a single transaction. Then think of your database as of your table as a very big table. It means that, of course, you will copy a lot of data, and I think you probably have full page writes enabled. Consequently, there's a lot of data written to wall, so pg wall directory grows. Also, memory is filled with this reorder buffer and all the decoded changes starts to be spilled to disk. So this specific directory with spill fast also grows. So your free disk space decreases very rapidly. And what is the worst thing here is that it's not even needed for your consumer. It all is decoded, all the resources are used, but of course, as this is a temporary table, you do not even need this. So it also filtered out and never sent. Then to the second part, and I think the most important part to understand is the logical replication slot. And this is essentially just a structure that defines the state of the associated consumer and defines the resources still needed for it. And by the resources, I mean write-ahead log and tuples affecting system catalog that also needed for the decoding operation. It is important to know that slot is persistent, it's crash safe, and it exists independently of the connection using it. So to say, if you disconnect, your client slot stays in place, but just does not update its state and does not move the positions which define the required resources. More insights on the process can be found in PG replication slots system view. It gives you information about whether the slot is active. So if a wall sender is running for this connection, so the connection is established, and the positions which I mentioned, which define the resources still needed. Oldest catalog xmin is about oldest transaction affecting the catalog, system catalog, which is still needed. Then restart LSN is the oldest write-ahead log still needed. And the third one, and very important one, is the consumer confirmed the position up to which the consumer confirmed processing the data. This is called confirmed flush LSN. Why it is important to know that it's persistent, the slot, is because just think of the situation when you disconnected from the slot and then connected to it again and want to continue your decoding process. For that, you define the starting point, which you probably have saved locally. And the thing is that if persistent data of the slot defines a position newer than what you provided, your position will be disregarded and the saved position will be used because it's essentially your actual state. So it's important to properly implement your client and properly store the current state on your side. And about the part that it defines the resources still needed, think of the situation when you have a slot that you disconnected from and it stops at updating its state. So Postgres thinks that all the resources created after this position are still needed. And it essentially means that your PG wall directory will grow endlessly before you connect to the slot again and start to update its state. And it's actually very easy to get into this situation. We've seen a lot of cases when people were thinking they're doing better, but in fact, they were just creating an inactive slot. For example, they could downscale their consumers for cost-saving reasons over the weekend or after performing some tests and waiting for the production launch and many, many other situations. But it all is about the situation when slot is not advanced and PG wall just accumulating in the PG wall directory and disk space is running out. So one minor but actually very important thing about those who make use of Partitioning. Partitioning has a nice feature of logical slots failover, and for that you will define slots in your Partitioning configuration as the permanent slots. And when your users, even when they remember to delete slots, if the slot is still in the Partitioning configuration, it will be immediately recreated. For that reason, it's worth thinking about any kind of interfaces for Partitioning configuration for your users, or even better, some automation around that. And users will, of course, ask questions about the necessity of the slot deletion. And the first will be, I'm not producing any changes to for my publication. It's easy. As I said, WAL is a single stream of changes for the whole cluster. And it's not necessary if you produce changes for your publication or for anything else in your database. It just writes all changes into a single write-ahead log. And if you're not deleting slot, write-ahead log size just grows. The more sophisticated question would be, they would say they are not expecting any write activity at all during the weekends. It's almost always not true, because you may not be aware of the scheduled maintenance task, or some minor write activity can cause an auto vacuum to kick in. And this all, any write activity activates the process, which after an archive timeout elapsed, of switching the WAL segment, so that the database starts to write to a new file. And tricky part here is that every file, regardless how much you read into it, will be of the same size, which is 16 megabytes by default, or the size you defined on the initialization stage. And it's not only about slot being inactive to have problems. You also can have your slot just moving very slowly in comparison to how quickly you produce writes. And one of the reasons for that, it can be that your consumer just underperforming. For that, just first, of course, tune your consumer application and remember to make use of publications, or actually filtering, not only on the table or schema, but also on the action you want to publish. And the last thing about slots is failover. Of course, if your database fails over to a new instance, you want to continue decoding process and not to miss any changes. Unfortunately, there is no out-of-the-box solution yet, even though we're expecting it in the closest major release. But for now, there are a couple of solutions for that. If you are using RDS or any system that uses file system replication, that's not a problem for you. For others, you can use Patroni logical source failover mechanism, as I've mentioned, which has its cons. Its cons because of the function used internally, or the more advanced solution, PG failover slots extension. And now to the last part, the replication protocol. Just quick overview of how it looks like. There's a message with data, with changes sent, and actually, apart from data, it also contains the position in the write-ahead log, which is associated with this change, and this position should be used by consumer to update its internal state. Then the consumer is obliged to respond back to the WAL sender and just inform about its current state, which is in its turn used by WAL sender to update the replication slot state. And looking into this schema, you would probably say that if there is no data, if there is nothing produced in the publication, no changes produced for the publication, slot will not be moved forward. And for that reason, there's a special message called primary keep alive message, which sends the current position of the WAL sender decoder to consumer, and this position can also be used for updating the internal state and respond back to the wall sender to allow replication slot to be advanced. But unfortunately, it's quite often forgotten. And for example, up until to the latest version of, not the latest, but one of the latest versions of PGJ-DBC, there was such an oversight that this message was received, but the position was never used to update the internal state of the consumer, and the position reported back to wall sender was stale, and replication slot was not moved forward. And yeah, it's basically created a lot of problems for occupying more and more disk space with walls. But another problem was about the endless shutdown. You see, when Postgres, when you shut down Postgres, not in immediate but any other mode, it will wait for clean shutdown, and clean shutdown means that all consumers reported back to their wall senders that they received changes up until the checkpoint, shutdown checkpoint position. And because of the oversight I mentioned, it wasn't happening, and Postgres was just endlessly shutting down. One of our engineers at Zalando fixed this in the 42.7 version of PGJ-DBC. And also a couple of years ago, it was also fixed by another Zalando engineer in PsychoPG2. Why it is, what was painful for us, actually because PGJ-DBC is used by our favorite CDC tool called Debezium, so it hits us very much. Yeah, this is pretty much it. As a conclusion, I would like to just sum all the set things up. First, use this nice technology cautiously, beware of the hazards, and make sure you understand how it works. Also monitor the slot state, if it's active, if it's advancing, it is advancing, and also check your free disk space. You probably already do this, but remember about this special directory for spill files. Always delete unused slots, not leave them behind. Another thing I've not mentioned, but also very important, know your workload. And sometimes it can be better to use the old good solution based on triggers, for example, PGQ. It may happen that it will create less problems for you. It will be easier to maintain. And lastly, just make sure that you use the proper protocol implementation. Remember about the story about PGJ-DBC. So that's pretty much it. Thank you for your attention, and I will be happy to answer your questions.
Yeah, Polina is in the Discord channel answering questions, so very good. Thank you very much for that talk. That was very, very good. A lot of stuff that I didn't know that I need to check out more in detail. Now, I haven't got time yet for this particular one, but I will definitely provide feedback for this talk. So it is very easy. I already fill in 5. Where are you now in your count?
I'm at 3, but I did fill out the feedback for this one already.
Okay.
So, because I was like, the outro, I'll quickly type a little message. No,
I did already those for today, and I did all previously some from the previous talks from the days, the previous live stream. Now it is super easy. You go there to the page. You have to go to the selection of the talks, which is by live stream. So you will find order by live stream and order by the presentation, and then you find your talk. And then you just have to answer 4 questions in terms of quality of content, quality of the speaker, and optionally you can also put some text for the speaker so that they get more feedback. So that's very useful. So, okay, so I'm beating you, Jelte, and then once I finish giving my survey for Polina, we have 6 in my count. Right, so next speaker, it is going to be somebody who, I was looking at the word expert, and the etymology of the word mentions that you acquire knowledge by experience. And Hans has been using Postgres since 1999. So that definitely counts as experience.
Yeah, he's been the CDO of Cybertech for I don't know how many years, but a long time. So Cybertech is one of like a very well-known Postgres consultancy company, and so their blog posts are always really good. I've read so many of them, figuring out some Postgres internals that I was having problems with. So yeah, here comes Hans-Jürgen Schönig, and I'm very excited what he has to tell.
Hello, everyone. My name is Hans-Jürgen Schönig. I'm the CEO of Cybertech, and hopefully for this year's conference, I've prepared some really interesting performance stuff you've never seen before. So if you're seriously interested in performance, check out this talk and learn something that is way beyond just adjusting some Postgres configuration parameters. Have fun. So hello, everyone, and welcome to this year's conference. My name is Hans-Jürgen Schönig. I've been in professional Postgres for 25 years. And I guess this is a follow-up talk to the presentation I gave last year, which was about performance features you've never seen before. Just to prepare you for stuff, I hope you've never seen many of those things before, because the intention is really that you learn something new, that there is something interesting for you, and that there is certainly some content that goes way beyond just changing some memory configuration or something stupid like that. So let's hope it's interesting, and let's get started. As far as my background is concerned, we at Cybertech here, we're running a worldwide Postgres consultancy company. We do support, training, all kinds of Postgres development, etc. And we're based here in Austria, but we're operating internationally. But let's get going. Postgres performance. Let's share some things which are new. And as I've mentioned already, the goal of this talk is really to give you some trickery that some old Postgres consultant would use, or to give you some things that might be thought-provoking, or to show you some stuff that is just more than there is bad performance, throw in memory and CPUs, or add disks. I mean, of course, disks and memory are never a bad idea, but there's a lot more to that. So as a Postgres consultant for 25 years, I can assure you there are things that are way more interesting than just throwing memory at the problem. So let's do a little tour through Postgres, and I will show you some random stuff that can be super beneficial and that might be a little bit eye-opening and hopefully entertaining and interesting. So let's get started. Just like last year, eventually everything starts by creating a simple connection. So people might wonder, okay, what's the point? We're creating a connection. We're doing basic stuff. How can we speed it up? But let's take a look at a variable most people might not have seen before. It's called session preload libraries. And what's this thing? How does it work? So let's get started. So imagine, as you know, in Postgres, you can write stored procedures in many different languages. You might write stuff in pgvector, you might write it in SQL, you might write it in Perl, Python, whatever. But if you're doing some kind of machine learning or statistics, or if you just happen to like R code, there is an extension out there. It's called PLR, which allows you to write stored procedures in R, which is perfect for all kinds of statistics and machine learning and all kinds of fancy math. So if you are doing finance, or if you're doing biology or anything of this kind, R is perfect for you. So what's the problem here? So I've written a very simple function. It just says if this value is greater than the other one, return this one, otherwise return the second one. Well, what's the problem here? Let's take a look. When I'm running this function after creating a connection for the first time, you will see that this simple function will take 229 milliseconds on my machine. If I call it for a second time, and you can see it's absolutely the same thing, it has gone down to way below a millisecond. And this already includes parsing, transfer time, permissions, everything there is. So obviously we are a couple hundred times faster on the second call. And imagine you're creating hundreds of connections, and every time you create a connection, and when you do the first call, Postgres has to load this library and initialize it. And this is exactly when we can go for shared preload libraries. What it does is, instead of loading the library during the first call, what we do here is we load the library already when we create the connection. So what we do here is basically we move the expensive part from user experience to the background, right? So it's still not free on first call, but it's already a lot better. And the real life example for that would be Postgres. So if you're running some kind of application that is using geometric data, Postgres is the industry standard in the open source world to do GIS data. And if you're doing a calculation based on geometric data, this setting can help you a lot to improve user experience, because there will be many, many first calls when you call your first Postgres function. So the first thing is shared shared preload libraries to improve on the first call to your connection. But let's see what else there is. So what you can see here, 10 milliseconds, 0.6 milliseconds. If we use the library, what you can see is that the first call is more than 3 times faster than originally. So obviously there is a benefit to that when we engage with this variable. So let's move on to the next one. It's about storing data. So it's not only that we can improve the situation when we create the connection, we can also improve stuff when we run stuff and when we store data. In Postgres, there is a tool called pgbench, and we can use that to basically run a synthetic benchmark and see what it does. So in this example, I've initialized a small test database, and I'm running 4 concurrent connections, 25,000 transactions, and our pgbench thing will get 4 threads. So we're running basically 100,000 transactions. And what we see here is 2 variables. The first one is the wall level, which is related to the Postgres transaction log. And the second one is also max wall size, which is also related to the Postgres transaction log. And what we'll compare is logical versus minimal. And then we will run the same thing with 2 different settings for max wall size. So let's see what happens. If we run this stuff with full transaction log, for logical decoding, for streaming replication, for binary backups, etc. And if we run that at the minimal wall size, the very small wall size, our 100,000 transactions will produce 130 megabytes of transaction log. What is pretty cool here is that this PG current wall LSN will give you the position inside the transaction log. And what is really, really nice in Postgres is you can use these data types and run calculations. Right? So obviously what we did is we take the current transaction log position, subtract the initial 0, right? And then we see that it's 135 megabytes, which have been created since the start. But let's imagine we only have a single server, no streaming replication, no logical decoding, no backup, just a simple local test machine, which you might use for some embedded operations, uncritical data, whatever. We could change those settings and see what happens. 135 megabytes all the way down to 82 megabytes. So by just reducing the wall level and by increasing max wall size, we can actually not just improve performance, we can also shrink the amount of transaction log that is written to disk, which will in turn make things smaller on disk, make things faster, reduce all kinds of overhead there is. And the question is, why did it happen? And there are actually two reasons for that. First thing is, minimal puts less stuff into the transaction log. And max wall size, by making it larger, what it does is it will increase checkpoint distance. And that actually means that we don't have to write so much transaction log, because the rule is, if an 8 kilobyte block in Postgres is touched for the first time after a checkpoint, we have to log the entire 8 kilobyte block and put it into the transaction log. Every additional subsequent change, what has to happen is we only log the difference, right? So if you touch a block more often, you will basically increase the chances that the first time after a checkpoint happens. So it's fewer full page writes, and that will actually decrease the size of the transaction log. So by increasing max wall size, actually we also already optimized the your write operations, because there's not going to be so much volume that's going out there. So increasing max wall size means we're often able to reduce the size of the transaction log, but we're also often able to just do all kinds of other trickery that makes life a lot better here. So this is excellent. So you might try it out. Big max wall size entries. You will need more disk space, but it can make your database application so much more efficient by reducing IOPS, right? Next thing is indexing. What people often forget is that indexing is really the most important thing on this planet when it comes to database performance. Without indexing, there is no such thing as database performance. It just doesn't exist, right? It doesn't exist, no matter what. Hardware is not going to fix the problem. If indexing is broken, you're doomed to suffer, right? There is no other way. And let me elaborate on that using a simple example. So imagine you have 1,000 queries that take 1 millisecond, right? So 1,000 good queries, 1 millisecond each. This is going to take 1 second. But if there's one traitor, one bad query that takes 1 second, right? This means that it's 50-50. 1,000 queries produce 50% of the load, and one nasty query will also produce 50% of the load. Okay? So one query can be super responsible for this entire database performance thing, right? So indexing is important, because what we really want to do is get rid of this expensive query, because it will double our speed or half our load. So super important. So imagine those 1 millisecond queries would all of a sudden take 1 second. I mean, you had to put in 1,000 CPU cores to make this happen. So it's not like you add 1 CPU core and everything is golden. It's really, really important here. So what can we do here? Let's generate a table. It's called tstatic. And let's import 25 million integer values. Very simple, 25 million integer values. Everything is golden. So when we create an index here, what happens is that by default, Postgres is going to build this index in a way that those entries in our index pages are only filled up to 90%, right? And the reason why we do that in Postgres is that if you create an index and then you insert a value, what we want to do is you want to avoid that those pages have to be broken apart because there is no place anymore. So we want to avoid page splits immediately after index creation. So by default, Postgres will make the index, but it's only 90% full. So often data is absolutely read-only. So imagine you have a phone book, you got history books, you got anything that is certainly never going to change. no imports, no inserts, just historic data. You never touch it. It's just there, right? You don't insert, you don't update. You just have static data set. You index that. You never touch it again. What you can do in this case is you can use a fill factor and say, hey, Postgres, make sure that your index is super, super full, not just 90%, but make 100%, because we know that there are not going to be inserts and updates all over again. And this will basically reduce the size of your index by, say, 10%, because you're filling up all the pages. And this can give you an additional performance boost because you're making things slightly smaller. And this is wonderful for static data. Don't do it on data that is constantly modified, because that's the reason why the default value is 90%. But if something is really, really static and historic, you can increase the fill factor to make it more efficient. So again, this is the summary, 90% because we want to avoid node splits, and 100% if something is super, super static. So this also a couple of percentage points, you can get it for free, and everybody is happy. Next thing is, so we've created a connection, we've loaded some data, we index the thing. So next thing we want to do is maybe we want to run a join, right? We want to run SQL statements, we want to run joins, and we do so possibly millions of times. So this is really fancy. I like this a lot. I learned that from a guy in the Czech Republic. Excellent stuff. Let's imagine you run an SQL statement that generates SQL statements, right? So we do select, create table. So we basically generate the SQL you can see from line number 5 to number 9. And what psql, the command line client for Postgres, can do is it can do \gexec. What it does is it uses the last result set you got and assumes it's SQL and executes that. So we create 5 tables. We generate the SQL statements for those create table statements. We run \gexec. PSQL is going to throw this back to the server, create 5 tables, and off you go. So you can basically generate your SQL statements, execute them directly without even leaving the command line. So we've created 5 tables in a very nice way. So, word of caution. What I'm going to show you here is slightly dangerous. So you should really know what you're doing here and understand this type of stuff, because otherwise it can really backfire. Okay, just a word of caution. Everything planner related can be good or bad. Depends on how you do that. So let's take a look. Let's have a query that says select star from X1, X2, X3, X4. So we're joining 5 tables. And what we see here is that the execution time is 0049 milliseconds, but the planning time is 6 times higher. So obviously, if we have a query that doesn't involve a lot of data, but does a lot of joining on empty or basically empty tables, planning time, just for the optimizer to decide on the strategy, is going to be super, super dominant, right? So planning time can be a lot longer than execution time. So the question is, can we do something actually to tell the optimizer, hey, don't dare to be smart here. Let's be stupid. And this is a thing which is rarely understood. It's called join collapse limit. Most people have never seen this stuff before. And what it does is, what we see here is X1 join X2 is an explicit join. So basically it says join X1 with X2 and then with X3 and so on. But Postgres says, you know what? If you write an explicit join, I'm still going to optimize that for you. And what we see here is X1 is X2, X2 is X3, X3 is X4, X4 is X5. So Postgres figures, hey, X1 is really X5, and X4 is X2, and X3 is X4, and etc. So it will implicitly compute something we call equality constraints. and try out all the join orders to figure out which one is the best one. By setting join collapse limit, what we do is we tell Postgres that don't change the join order for explicit joins on your own. Use the join order I've given you. So this can be super dangerous because you might end up with a suboptimal join order. But if you know that this is the way this join has to be executed, you can set join collapse limit and nail the execution plan the way you want that, save on planning time, improve performance, 5-fold, 2-fold, 50%, whatever. And have an efficient plan that is basically running locally. Yes, there is such a thing called prepared statements, but this is really for queries that are really fully planned or first-time planning, stuff like that. Okay? Next thing is we've created connections, we've loaded data, we've indexed, we've run an SQL statement, we've planned the SQL statement, and now it's time to execute the SQL statement. So let's see if we can maybe do something here that will change this stuff for good. It's a bit hard to read, but let me put it on one slide. I'll create a table, empty, 10 million entries, right? So t-test, generate series, 10 million entries. So we got 10 million numbers. And what you see here is basically two identical functions. One is a return many function, and the other one is returns few function. So it's the same function. The only difference is in line number 11. In the left function, it says, if the number is even, return the value. So it returns 50% of data. So you feed it a million rows, and in 50% of all cases, it will say, okay, let's do that. The other one does modulo 1,000 equals 35. So it's not going to return 500,000 rows if you throw a million at this stuff. It's only going to return 0.1%. So obviously, both functions do the same, but the odds of returning stuff are way higher on the left side. So if you run a query that says, select everything from t-test where returns many equals ID, and then returns few equals ID, what it means is that Postgres doesn't know that those functions are different. So it will just execute them in the order we put them. So it will call the returns many function 10 million times. It will return 5 million rows. So we will feed 5 million rows to the second function. That's bad, because if we executed the returns few function first, there wouldn't be anything left for the returns many function, right? So obviously, by changing the execution order, by doing the few function first, the overall effort goes down because the function that returns more data is simply not called often anymore because there's nothing left. So let's see how we do that. So what you see is obviously we call this one 1 million times, we call the other one 10 million times, we call the other one 5 million times, and you see that overall it's 2.3 seconds of execution time, or 2.4 seconds. So let's try something. Let's do alter function, return many, cost 1,000. By default, Postgres assumes that function call is 100 times more expensive than an operator. So if you do A equals 10, it has a certain cost. But if you do function equals 10, Postgres assumes that this is 100 times more expensive than an operator. So, but now we're telling this thing, you know what? This is not 100 times more expensive than an operator. This is 10,000 times more expensive. So obviously, the price for return many from the optimizer point of view has just gone up, while the cost of the other function has gone down. And what Postgres does is, instead of running this for 2.6 seconds, it only needs 2.1 seconds now, because obviously the returns few function is called before the returns many function. So we changed execution order, but just assigning different cost to those functions, right? And this will obviously give us the chance to influence performance in case we got many start procedures. So this is how it works. There's a thing called CPU operator cost, and it's multiplied. And what we do is basically we influence the behavior of those functions. What we do is we just change the relative costs of things to each other, okay? So this is not absolute cost. This is about relative cost. Okay, so that was my features, which you hopefully have never seen before. Creating connections, loading data, running planning SQL, indexing, planning SQL statements, executing them, and finally some magic for start procedures. I hope you've enjoyed that, and hopefully when we see each other again, but before we see again, we are actually hiring. So we're looking for Postgres engineers, support people, consultants, migration specialists, whatever you like. So feel free to send me a message, and I hope you had a nice conference. I hope we will see many other interesting presentations. And thank you for your attention, and looking forward to getting in touch with you. So just send me an email, share this talk with your friends, and recommend this conference to everybody you know, because it's really a sensational event. And hopefully see you next year.
Well, thank you very much, Hans. That was very, very interesting. And we can see in the Discord channel that effectively there were some stuff that were never seen before. The good news is that there were even some stuff that Hans haven't seen before when it had the discussion. So we can see that how the community really interact based on these presentations, which is the reason why we are here, right? To exchange knowledge between each other. And this is not the only way that we are exchanging knowledge today. There's also been other presentations in the first 3 live streams, right? And we are going to kind of give you a hint of what was done in the previous one, the live stream 3. So these are the talks that were presented some hours ago.
Hi, I'm Sarah Novotny, and I'm a longtime open source community contributor. I've worked in projects and communities like MySQL, Nginx, and Kubernetes, to name a few. And today I'm going to talk about Kubernetes and the different things that I have learned and loved from that project.
2 years ago, I gave a talk at CitusCon called Explain the Postgres Query Optimizer. And today I'm giving the follow-up to that talk, building on the basics of Explain the Query Optimizer, talking about all the other things that the optimizer does that I didn't get a chance to talk about 2 years ago. So I'm looking forward to this talk, and I hope you enjoy it too.
I help customers migrating their workloads to Azure, and I've been working with many customers around the world across different industries in complex PostgreSQL implementations, and I've been helping them in resolving their performance and scalability issues.
Hello, I am Pamela Fox, and I'm talking about pgvector for Python developers. pgvector is a great extension that you can use in order to store vectors in your database and then do distance operations on them. It's incredibly useful if you're doing any sort of similarity search, especially for generative AI applications like retrieval augmented generation, in order to search and chat with items in your database. So come to my session to learn more about pgvector for Postgres and Python.
We are here today to walk you through a presentation on PostgreSQL physical replication, the internals of this, recent developments, and what sort of future work can be done around physical replication.
Hello, my name is Grant Fritchie. Today I'm going to talk to you about using Query Store to understand performance inside your PostgreSQL database. This is really important because unless you know what's happening inside your database and you know how your queries are behaving, tuning those queries and getting them to run fast is going to be really difficult. But Query Store inside of your Azure Postgres database will absolutely help you get it done. Come to the session, find out how.
Hello, my name is Taylor. I'm here to talk to you about Postgres, specifically task queues in Postgres, specifically how to implement and use them for great benefit so that you do not have to use something like PubSub or Airflow or Kafka, whatever those other things are. You could just use Postgres. It's very nice. So yeah, let's get into it.
My name is Denzel Ribeiro. I'm a principal product manager at Microsoft working on the Postgres service. And today I'm going to talk about 6 things you can do with the Azure AI and Azure Local AI extensions, which are first-party extensions. They greatly simplify building Gen AI applications on Postgres.
And today I'm going to give a talk on how to use Postgres views to revitalize your complicated or outdated data models. I think this is very relevant for software developers who are working in startup environments where your data model is constantly changing.
My name is Varun Dhawan. I'm a product manager with Azure Postgres team at Microsoft. Today, I'm going to talk about top features that make Azure Postgres great for developers. I believe this will be an interesting talk for anybody who wants to start developing on Postgres, whether community Postgres or Azure specifically on Azure Database for Postgres.
All right, so that was the great content from the live stream 3, and we will continue with more great content in live stream 4, which is now. And of course, if you want to comment about the presentation from live stream 3, 2, or 1, or one of these sessions, always use the hashtag PosetteConf and also join the Discord channel for all the discussions that we're having there. Very, very nice conversations there. All right, so don't forget that in-person conferences have a lot of swag, but we have it also here in the Posette, and then you can check there how you get all the information for all those stickers and socks if you want to get some swag for the conference. Now, let's continue with our next speaker, which is actually somebody who has an impressive academic career. He have done many things in academia, and the good thing is that he's a very good example about how the research actually spin off into something that is super applicable when he founded DBtune in Sweden. So as a person who does research, he also explained things very, very well. I met him in PG Day Paris this year. I talked very nicely with Luigi at that time. Have you met Luigi, Jelte?
Yeah. I met him with PGConf India, and we did lots of. I mean, we talked about technical stuff, but we also did lots of sort of touristy stuff there together. We went to a metal concert in India. We went to a park and saw some snakes. Went to some palaces. It was really really fun. Sort of the weekend after the conference, we had some touristy things we did. It was really.
I'm jealous because we didn't go to any metal concert in France, but okay, good to know. Okay, so next time that I meet Luigi, I'm going to ask him about this kind of experience. But now he's going to be talking about Azure Flexible Server. So let's hear what Luigi Nardi has to say about this topic.
Hi, everybody. I'm Luigi Nardi. I'm the founder and CEO of DBtune. Very excited to be here at Posette. Today we'll be talking about auto-tuning Postgres. So if you are interested in learning about the configuration of your Postgres instance to achieve high performance, this may be the talk for you. Looking forward. Let's get started. All right. Right before starting, the talk will be focusing specifically about Azure Flexible Server. And this is a topic I liked talking about in the past as well, but this will be focusing specifically about the database as a service run by Microsoft, and we'll give some insights specifically on that part. Very briefly about me, I will spare the audience to go through this long list. I am a computer engineering major from La Sapienza University. I'm originally Italian. Had the chance to be going back and forth between academia and industry a couple of times in the past. So I have a mixed background in academia and industry. Started my career as a PhD student at University of Pierre and Marie Curie in Paris. Worked as a fintech engineer at Murex, and then moved to London. Worked at Imperial College London. Moved to the US, California, to work as a research staff at Stanford University. And that was the time when we spin off DBTune from the research done there. Became an assistant professor in machine learning at Lund University right after that, and founded DBTune a year or two later. All right, so before talking about auto-tuning, let's remove the auto and just talk about the tuning. So what is this all about? What is database tuning all about? Database tuning is the process of keeping the database fit and responsive. So databases change, grow, and slow down over time. They have not all workloads and applications and machines are the same. And so the process of tuning is the process of adapting a database instance to its current use case, load, and machine. And so this is considered a bit of a dark art where database administrators and developers need to go through this process, and it's usually considered a pretty tedious process to go through, and needs a lot of expertise usually. And if you look at what database tuning helps you with, it can be divided in multiple areas. So you sometimes want to query you want to tune your queries, and that's called query tuning. Sometimes you want to query the configuration of your system, also known as database management system parameter tuning. You may want to tune your indices. You may want to tune your operating system parameters. And while all these areas are in the umbrella of tuning, today we'll be focusing on database management system parameter tuning. And I believe that some of these tasks are not fully automated today in industry, but we can say that database management system parameter tuning can be fully automated, and this is the focus of this talk today. So why does this matter? So if you are an engineer or a database administrator, you probably spend a lot of time trying to get your performance right, and by tuning you achieve better throughput, better latency. You improve the scalability, the stability, and the reliability of your system, and you meet your SLAs. So these are all very important aspects of your software, hardware stack. And by optimizing database performance, you also make the finance department happy, the business department happy, and the sustainability department happy, because this has effects that go beyond the dev team. And for example, it decreases the cloud infrastructure spend by having well-tuned instances. You have higher end user satisfaction, which may lead to more business to your company. And this reduces downtime, increases productivity, and has also a sustainability aspect, which is by running your software more efficiently, you save energy. And so this is an important aspect as well. So this connection between the left and the right panels, it's something that it's sometimes overlooked, overly, engineers are not overly conscious about this, but there's a very specific connection between these two things, and it's fairly explicit. So making database systems to go to run more efficiently has a big impact on the business challenges as well that any company faces, especially in 2024. Right, so let's double click on the focus of this talk, which is database system parameter tuning. And the problem is similar to what you see on the picture on the right side. So you have this console with all these parameters that you want to tune to achieve good quality audio, for example. Now, the talk is not about audio. I'm not audio engineer, but similar things happen in Postgres. And so the idea here is that we want to tune all these parameters or knobs to best fit the workload. And this is an example of parameters that are commonly tuned in Postgres: work mem, shield buffers, macro size. The list is longer. Let me give you an example. For example, on this max parallel workers per gather. Here, this is representing the maximum number of workers started. And this is all about parallelism. It's all about using parallel computing inside one query so that things can go faster using multi-core computing and the cores that you have available on your instance. So this is an example of parameter, and we will talk a little bit about this parameter in the next slide as well. Another example is random page cost, which affects the way the planner plan how to run the queries, and this is the planner's cost of specifically non-sequential fetched disk pages, right? So if you have queries that have a non-sequential access, then in this case, this random page cost parameter can affect the performance of your system quite a lot. So the important things, we could talk about parameters for a long while. There are many parameters, and all of them are extremely interesting, and you need to kind of go deep and understand what they mean in Postgres. But the overall takeaway here is that these parameters, they highly depend on the application itself. And if you have two different applications, you won't be able to use the same parameters for those applications. And here I would like to give an example and try to quantify with this slide what that means. So I'm using, again, these two parameters, max parallel workers per gather and random page cost. And here the idea is that we are tuning for average query runtime, which means that lower the better. So you want to get this milliseconds to go down. So latency gets better when it gets smaller, right? And so if you look at the picture here on the left side, we have the two parameters on the X and Y axis. And on the vertical axis, we have the milliseconds that vary in a logarithmic scale from 1 to 8. So if you look at the minimum and the maximum, you have roughly 8x improvement or decrease in performance, depending on how you set these parameters, right? And what is interesting here is that if you get random page cost right, you really go quite far, because you see that if you manage to identify this area here with random page cost, which is perhaps 0.5 or 1.5, perhaps even 2.5, you move away from the higher levels of random page cost, then you really get a pretty good performance. You go from this 8 milliseconds to something that looks more like 2 or a little more than 2 milliseconds. But if you want to really nail the performance to the best value, then you also need to make sure that max parallel workers per gather gets into this region. So you need to identify this little corner here. And this benchmark opinions or opinions.com is a transactional workload, which is running many queries that are not super complex. And so in this case, the fact that the parallelism, it can be small per query, it's actually better for the performance, right? And so this is something that may be not obvious if you don't know these parameters very well, and if you perhaps don't have a very deep understanding of your application. So to get the performance right here, you want to go on a low random page cost and a low level of parallelism in track query. This is another example, TPCH, and TPCH is a benchmark for support decision, and this is characterized by much heavier queries, analytic queries. So you see that the number of milliseconds is much higher than the opinions.com, and what you see here is that random page cost has a fairly small effect here. But again, if you want to get the performance right, you need to go on this little corner here. And in terms of max parallel workers, you will be really affected if you use no parallelism here. Again, this is because TPCH has complex queries, and you want to be able to use your multi-core machine to run multiple workers together. So you see that in this case, the low bottom left corner is the one that really provides the best performance. And the performance level here can go from about 2,000 milliseconds all the way up here to almost more than 10,000. So this is a pretty wide range. And what this example shows is that you need to be able to explore these two parameters in a way that you get the performance right. And sometimes what works for one, it's not what works for the other one. All right. If you look at the trend in Postgres, we've seen that the number of parameters in Postgres is increasing over time in a linear fashion. And it's increasing just a little bit every now and then. And over the years, in 18 years, this increased by 2.5x. We have more than 300 parameters in Postgres to date. Now, not all those parameters are important for performance. And I will claim that perhaps 20 or fewer than 20 have a real impact on performance. So this is not as bad as this picture shows. But if you focus on the complexity of this problem and you focus perhaps on just 12 parameters here, so on the x-axis I have the number of parameters. If you focus on the number of parameters here on the x-axis, you see that even with just 12 parameters, you really get on a complexity which is 1 trillion possible configurations of the system, which is of course quite challenging. Imagine if you're doing this manually, it would be very, very challenging. And as a human being, I really struggle imagining how big these numbers are. But these are very large numbers, and this is a combinatorial optimization problem we're trying to solve here. And by increasing by 1 the number of parameters, going from 12 to 13, for example, you will go to a level of complexity which is roughly 10 trillion possible configurations. So this very quickly grows, and it can become really, really not really easily to manage. Right, so how is parameter tuning tackled today by database administrators and developers? So the status quo is to doing this tuning manually. So this may take quite a long time. You need to be an expert, and it can be ineffective in the sense that you may need to tune again in a week. Maybe there are seasonal workloads, and those workloads would be different, and you need to reconfigure your system again after a little while. And I like to use the tuning guru, my colleague Magnus Sagander, who is Postgres core team member and president of Postgres, who has been working with us for a few years, and he has been working on performance tuning for about 2 decades now, and is really my expert and my go-to tuning guru for this type of things. Of course, Magnus can perhaps do this faster than the average person, but you need someone like Magnus or someone that has a lot of experience doing this to solve this problem manually. So it's very challenging to find right people that can solve this problem effectively and efficiently. And of course, if you have a fleet of 1,000 databases, doing manual tuning may be really, really challenging. So how do you do that on a large fleet? That's challenging. A different category is heuristic approaches. Heuristic approaches are interesting because they automate some of the things that a person like Magnus will do. So they have some rules, and they apply these rules based on your RAM size, how much memory do you have, what type of disk do you have, how many cores do you have. And so based on that, they will give you some configuration of the system which reflects this machine size. And this, of course, suffer from similar problems than the manual tuning here. And they will be limited by the fact that the solution is provided just based on the machine size, which is a bit of a limiting factor because you don't have enough information to really provide the solution which is bespoke to your application, right? And that's the limitation of these approaches, but they're great. And some of these tools, like for example, pgtune, is open source and can be used out there. There are this Postgres configurator as well by Cybertech, which is just a great tools. But they only get you, a certain level of performance, and they're limited by those factors. And then there's the third category, and the third category is this ideal solution which learns by observation and automatically tunes your database instance. The way this is done is that this solution adapts to changing workloads, and this is the ideal solution because you're now observing not just the machine model, but also what's actually running on the machine. So the application is taken into consideration now, and this is a feedback loop that eventually gets you to potentially the best performance automatically, right? So this new approach is the one that we are focusing on at DBTune, and we believe that this can be done in a very effective way. Right. So the question, how often do you tune? And this is a question that depends on the frequent changes of your database instance. That you can look at how often your workload changes. For example, if your queries are changing very often, if your application is changing, for example, if you're still developing the application and changing features a lot, then your workload will change quite dramatically over time. Your database can grow over time, and we have colleagues, for example, have alpha terabyte of additional size in the database every 6 months, and then that's kind of the rate of growth of the database, and this is not really uncommon these days. And if you're scaling your cloud instances up and down, of course, you need to retune because now you have a different hardware that is supporting your application, and that hardware needs to be taken into account. And so these are frequent changes. And on the infrequent changes, in case you're migrating from on-prem to the cloud or vice versa, if you're moving from Oracle to Postgres, if you're upgrading your version of Postgres, perhaps you're upgrading every year, every other year, you want to perhaps also do tuning again because effectively you're running on very different systems now. In practice, though, what we've seen out there is that people have a very reactive approach to tuning. And reactive means that when something really goes wrong, then they try to fix it. And so you basically see the performance, going down to a point where it really becomes a problem for the business. And then at that point, database administrators and developers jumps in and fix this tuning aspect and bring the performance up again. And this slowly goes down again. And so it's not proactive in the sense that they're not actively changing the configuration of the system regularly, but they wait until something goes wrong. And we would like to propose a more proactive approach with the third category I was mentioning before. So this is very often looked then once or twice a year, so very, very infrequently. Often engage expensive external resources and experts like Magnus, for example, I was mentioning before. And different workloads are often not really treated differently. Sometimes they are, but it's difficult to capture something that also varies over time. And the modus operandi is really that we just basically throw more hardware and compute to the problem, which makes the operations much more expensive, but technically you solve the problem by just increasing the size of your machine, which is, solving the problem in the engineering department, that perhaps creating a problem in the finance department at this point, because now you're spending much more for the same level of quality, right? Right. We would like to have a wildly different approach to this problem, and this is a machine learning driven approach where machine learning is useful here for the simple reason that machine learning allows you to observe and react. So the loop looks fairly similar to what a manual tuner will do. So manual tuning, changing something, observing, and then incorporating this information in some sort of like mental model of what's going on in the performance of the system, and try to mimicking that behavior of manual tuning with machine learning is possible because machine learning will learn a probabilistic model of the performance response surface of the system, and that performance response surface can then be used to optimize the system. So make decisions, sequential decision making that will allow you to mimic a manual tuner in a way that you will eventually converge into an optimal configuration of the system. So this dynamic adaptation, meaning that if you throw a workload to this problem, to this system, it will give you the best configuration of that workload. If you throw another workload to the system, this will take into account that other workload. It's easy to use, and because it's based on the cloud, and for the same reason, it's also highly scalable. So the user gets this type of value propositions. So we have, by tuning the software, you achieve higher efficiency in terms of reducing cloud infrastructure costs, which is a great point. Make your service faster, especially if you don't tune regularly manually. This will really make your service faster, and it makes frees up the database administrator time. Now, database administrators and developers are very busy running many other operations, but this one narrow task can be fully automated. So this is something usually helps productivity and also reduces energy consumption, as I was mentioning before. So let's talk for a minute on how we can do this in Azure Flexible Server. So you have here on the left side your user Azure Flexible Server instances. And on this side, you have the machine learning optimizer and the dbtune open source agent that is running over here. Technically, this can also run on an instance that is managed by you directly. So this is an open source agent that can be analyzed and audited. And the way this works is that this open source agent connects to the Azure Flexible Server instance through the Azure CLI and through the Azure Monitor. So the Azure CLI will be used to change the configuration of the system, and the Azure Monitor will be used to monitor the performance of the system. So things like latency, throughput, and also things that are more related to the system, CPU and usage, memory usage, and things like that. And so this can then be connected back to the open source agent, which has this actuator, which is the one that commands the change of the system. And here we are only changing the pgconf file of the Postgres instance. So we're not changing the SQL queries, for example. We're not changing the other things that are part of the database as a service. We're really focusing on changing the configuration. So this is an active approach where we actively changing the instance, but we're not changing many of the things that are part of that system. We're only changing the configuration. And technically, the monitoring doesn't need to report anything related to the tables or the metadata of the tables. We're only interested in looking at performance-related metrics, which are then reported back. So the optimizer is recommending a configuration here. The system runs for a while. The Azure Monitor monitors. This is all reported back. The monitor monitors, and then the machine learning optimizer gets better and better at modeling what's going on the left side, and eventually will converge into an optimal configuration of the system. So this is an iterative approach, and over a number of iterations, you get to converge to the optimal configuration. So this is the overall high level. Of course, the system has a number of details. I would like to maybe talk a little bit about that, but let's focus for a second on the type of performance you can get. So here we're getting a TPCC benchmark. Here it's time in minutes on the x-axis, and you have the performance transactions in seconds. So here we are optimizing for throughput specifically, so higher the better. And here we're using the flexible server D8 DS. This is a baseline. And you see that if you run on that baseline TPCC, you will get about 550 transactions per second. So now if you double the size of that instance and use the D16DS, you get roughly double the size of the instance. And you basically double the size of the instance, you get double the performance, which is great. But of course, that is a more expensive instance. And if you use pgtune, this also improves the performance by a pretty good margin here. But if you use dbtune, the solution looks quite different. dbtune will start from the same performance as the D8DS it's running on D8DS, and it will go and go up and down, trying different configurations, and eventually providing solutions that are high performing. And so this feature should have been let run longer, but the final performance will be as good as this, and then it would be basically flat with, of course, oscillation and noise. It's always present in this type of machines and cloud experiments, but you then get the performance which is 1300 transactions per second, which is roughly 2.5x better than this one. So the interesting thing here is that you're running on a small instance, but you're getting a 2.5x improvement in performance in terms of throughput with respect to the baseline, right? Which is great. All right, very briefly, I wanted to briefly mention that this is safe to use in production, meaning that we have implemented a number of guardrails, system guardrails, which constrain the optimization in a way that the upper and lower limits of the parameters are safely taken care of. There is monitoring with respect to memory that is always there, and we monitor the fact that the memory shouldn't be used above a certain level during the tuning, so that we can quickly revert back to a potentially safer configuration if needed. And the last thing is that we observed the oscillation in performance during the tuning, but the oscillation is constrained in a sense that when we observe a lower level performance, we exit that configuration and go in a different configuration that is more stable in terms of performance. So these are all mechanisms are automatically taken care of from the system that was engineered with this domain-specific knowledge that is useful when you run in production systems. So there's an interesting blog that was written by our colleagues at Stormatics, where they run an independent evaluation of dbtune. I think this is quite interesting to see the type of performance gains that you can achieve, and also some comparison with respect to manual tuning. And this is a pretty interesting take on this. You can try this on self-managed instances today. The Postgres flexible server integration, it's not available yet, but if you want to play around with the system, you can create an account and try it out by yourself from today. This is all I have for today. Thank you very much for listening, and looking forward for the Q&A.
Thank you, Luigi. This was super useful. I remember when we were in a taxi, I was in India, I was talking to you about this, but I didn't know it was actually coming. So I was like, I have this nice idea of combining dbtune with Azure. You should talk to some people here. You were already secretly talking with them. So that was very funny.
Yeah, very impressive results. I mean, that's one of the things that I like the most. I mean, when he can show some baseline and then with that, just adding dbtune, how much you can get from the same system. It's really fantastic. Yeah. Right. So what do we have next, Jelte? What do we have next? Tell me.
Well, we still have swag.
Are you sure that it's not sold out? It's not sold out?
I mean, I don't know. The only way to find out is ask for swag and figure out if you can still get some. So
exactly,
yeah,
you have to go and check that.
Stickers, be sure to go to the website and fill in this code, and because this is the only way you can get swag in a virtual conference.
Yep.
And yeah, join the Discord if you haven't yet. That's where the speakers are. If you're just tuning in now, the speakers for every talk are going to be there to answer questions. They'll be there while they are talking because the talks are pre-recorded. So they have all the time in the world to answer your questions. So don't feel shy.
You can also see the discussions that happens before in the previous talks as well. So that's a very good thing. But now we have somebody who I appreciate a lot. I mean, we were discussing about the Lord of the Rings, our competition for getting more feedbacks. And I'm going to give a spoiler here about the Lord of the Rings. So if you haven't watched Lord of the Rings yet, just don't listen what I'm going to say until Jelte continues speaking. So there is a scene where the Lord of the Nazgul in front of the gates of Gondor is fighting against a warrior, a very brave warrior. And they are in the last moment of the fight. And then the Lord of the Nazgul says like, ha, you tried to kill me, but no man can kill me. And then the warrior take off the helm and it's Eowyn. And she said, I am no man. Oh, that scene is excellent. And when I think about brave women, I mean, I have to think about Karen, who is really there in place in the community, fighting for diversity, fighting for making a much better place for everybody. So I would like to thank Karen, and then it's a very good thing that we have her here for the next talk.
Yeah, no, it's great. She works at Crunchy Data, and but this talk is not going to be about diversity. It's going to be about technical stuff, about why you don't need a backup policy. I don't know. That sounds scary to me. I've definitely I lost the database once. I will never do that again. That's yeah. You learned that once, and luckily it was not the most important data. But it took a long time to sort of get back to a state where we had some stuff. So I'm very curious what she's gonna talk about.
Yeah, me too. So,
hi, I'm Karen Jex, Senior Solutions Architect at Crunchy Data, and I'm speaking at Posette about why you don't need a database backup policy. You're probably wondering why, as a DBA of over 20 years, I'd be telling you that you don't need a database backup policy. So hopefully this talk's going to be interesting to anybody who has data that they care about and want to keep safe. I've always worked with databases. I spent over 20 years as a database administrator, and I'm currently a senior solutions architect with Crunchy Data. So of course today, I'm going to talk to you about why you don't need a database backup policy. And I can already hear you thinking something like, don't be ridiculous, Karen. Of course I need a database backup policy, although you might be using more colourful language. So let's look at why I might tell you that. First of all, just to make sure we're on the same page, what actually is a database backup policy? It's going to include things like the methods and the tools that you use to take backups of your database, how often you take backups and what kind of backups you take, where you're going to store those backups. Are they local? Are they in the cloud? Are you storing them to tape? And how long are you going to keep all of those backups? But how and why do you make all of those decisions? Let's try and find the answer to that question. So we'll look at why you take backups in the first place, what your recovery requirements are, the different methods and tools that are available to you to do database backup and recovery, how you might go about creating a disaster recovery policy, and the importance of testing and maintaining that disaster recovery policy. I'll concede that you almost certainly do need to take backups of your database. But let's think about why you take those backups. It's not just for the fun of scheduling some extra processes or to use up your storage quota. Your data are probably critical to you and you want to know that they're safe and available. So I'm assuming that you take backups so that you can recover your data if something goes wrong. But what could that something be that goes wrong? Fire, flood, explosion, tornadoes? Usually, hopefully, it'll be nothing quite so dramatic. But it could be one of all sorts of different things that goes wrong, from a data center being unavailable, to your storage array failing, to Bob dropping a table, or a batch process incorrectly modifying data. In each of those situations, if you don't have another way to survive the failure, you might need to restore from a backup and recover your database to a point in time just before that point of failure. Remember, of course, that backups aren't the only way that you can safeguard your data. A database restore is actually often a last resort. You can survive a lot of failures if you've got a high availability architecture in place with one or more standby databases that can take over if there's a problem with your primary database. So now you know that you need to be able to recover your data if things go wrong. You need to know what's expected of you if there's a recovery situation. And there are a few main things to consider there. The first is your RPO, or recovery point objective, sometimes known as the maximum permitted data loss. So this is going to answer the question, how much data can you afford to lose? For a mission critical database, that might be expressed in milliseconds or even as zero. Or on the other hand, for a development database, it might be expressed as a number of hours or even days. The second is your RTO, or recovery time objective. That one answers the question, what's the maximum amount of time it can take you to have your database back up and running? Or how long can the database be unavailable before it starts to become a problem? Generally, remember that the RTO actually says how quickly the entire application needs to be back up and running after a failure. So your database needs to be back up and running well within that time. As with the RPO, that could be expressed in milliseconds for critical databases or hours or days for non-essential databases. And then finally, you've got backup retention. How far back in time do you need to be able to go? Now, this might be for compliance or GDPR reasons. You might, for example, have to keep 10 years worth of data. On the other hand, you might not be allowed to keep certain backups for more than 6 months. And there may be nuances to how long you keep data. You may need to keep certain data online because you need to be able to restore recent data very quickly. And you might need to keep certain data for a certain amount of time offline because it might be okay for it to take several days or even longer to retrieve, for example, 6-month-old data. These recovery requirements are usually defined by the business, so they might be expressed as an SLA for either internal or external customers. If those requirements aren't explicitly defined somewhere, make sure to find out who's responsible and get it formalized. A poorly defined or moving target at best is extremely frustrating. Before you can put together any kind of policies or procedures, you need to know what the different options are for backing up and restoring your database. So let's do a quick recap of some of the different backup methods. When I talk about database backups, I'm usually thinking of physical backups. A physical backup is a file system level copy of the files that comprise your database cluster, i.e. the contents of your data directory. A physical database backup can be offline, where the database is shut down during the backup, although that's fairly, it's not very common to see that anymore, or online, where the database stays open and accessible to users during the backup. An online backup needs to include the WAL files that are generated during the backup itself, so that you can recover to a consistent state if you need to restore that backup. An extension of the online backup is continuous WAL archiving. That's saving a copy of your WAL files alongside your backups. You can then use a backup plus the archived WAL files to recover your database to the state that it was in at any given time since that backup. So that's what we call point-in-time recovery, or PITR. There are different types of physical backup. A full backup is a complete copy of your database files, which, along with those WAL files that we discussed earlier, gives you everything you need to restore your database and recover to a consistent state. But full backups can take a lot of time and they can take a lot of space, even if you compress the backups. So let's imagine you take a weekly full backup. You take a full backup every Sunday. If you want to take additional backups during the week, you might decide to take incremental backups. An incremental backup only copies the changes that were made since the last backup of any type, rather than taking a copy of the entire database cluster. So you might, for example, decide to take an incremental backup on a Tuesday. You might take another incremental backup on a Thursday, which would back up only the changes that were made since Tuesday's incremental backup. If you needed to recover to Thursday, you'd need Sunday, Tuesday, and Thursday's backups to be combined to give you everything that you need to restore your database. You might decide on a Saturday, you're going to take a differential backup. Now, a differential backup backs up all of the changes that were made since the last full backup. So this one will ignore the fact that we took an incremental backup on Tuesday and Thursday, and it will back up all of the changes that were made since Sunday's full backup. If you needed to recover to Saturday, you could take just Sunday's full backup plus Saturday's differential backup to get back to Saturday. And then on Sunday, you're back to your full backup, ready for the new week. A storage snapshot is essentially an image of a file system at a given point. Different storage vendors implement storage snapshots in different ways with different solutions, different architecture, and different functionality. In some organizations, storage snapshots are used as part of a database backup strategy. Storage snapshots can be a very fast way to back up a file system, but there are a few things that you need to be aware of that can trip you up if you choose to use them as part of your database backup strategy. You need to make sure that your file system supports the ability to create a consistent snapshot of the data directory. You must back up the WAL files alongside the other database files so that the WAL can be replayed when your backup is restored. Remember that Postgres will do a crash recovery when the database is started after it's been restored from a storage snapshot. In order to reduce recovery time, you can perform a checkpoint before the storage snapshot. If the WAL files and data files are on different disks, or if you have table spaces on different file systems, you need to make sure that your storage vendor supports creating simultaneous frozen snapshots of all the volumes so that you've got a copy of all of them at exactly the same time. You need to read the file system documentation carefully, and as with any other backup strategy, you need to test your entire backup and recovery process. A logical backup, otherwise known as a database dump or an export, is an extract of some or all of the data or the objects within your database cluster. It's dumped in the form of SQL commands that can be executed so that you can recreate those database objects. The restore from a logical backup, sometimes called an import, and the dump can either be imported back into your original database cluster or into a different one. So just a quick recap of the features of the different methods that we've talked about. So as you can see, the only method of backup that will give you the ability to do point-in-time recovery is continuous archiving. So you need online backups and continuous archiving of your WAL files. If you need to be able to do things like restoring a single object, or you need to be able to restore across different platforms or versions, you'll need to take logical backups or exports. And you'll probably need to combine these methods to give you everything that you need. There are various Postgres backup and recovery tools available, and the tool or tools that you choose will very much depend on your requirements. There's a whole host of things that you might need your backup and recovery tool to do, from point-in-time recovery to a centralized backup architecture with backup catalog, to backup and WAL file retention policies. You might need multiple backup locations, including cloud storage, compression of your backup and WAL files, or backup and restore of individual databases, schemas, or tables. So the main tools available for Postgres backup and recovery: PG Backrest is a fully featured, reliable, open source backup and recovery tool that's used by much of the Postgres community. Barman is another open source backup and restore solution. And PG Base Backup is integral to Postgres, and that lets you build your own backup and recovery around its functionality. PG Dump exports or dumps a single database, or if you prefer, just certain objects from it, either as a plain text file that contains the SQL commands that allow you to reconstruct the database, or in a custom archive format that can be restored and imported by PG Restore. PG Dump All will export all of the databases and all of the global objects, so users, etc., from your database cluster. Okay, so now you can start to design and, most importantly, document your disaster recovery strategy. What do you need to put in it? We'll just quickly go through each part in turn. First, you'll need a clear statement of your recovery requirements. Your recovery requirements will vary almost certainly depending on the type of application. So you might organize your applications into categories, and that will depend on how critical they are. And then you can define recovery requirements for each category of application. Mission critical client-facing applications will be categorized as level 1. And you probably also want the office coffee machine system to go into that category if you want your tech staff to keep working efficiently. And that will go through to non-essential internal systems, for example, things like your internal print services classified as level 4, low priority. This is probably going to be part of a wider categorizing of applications within your entire organization, and it might impact other policies such as security and high availability. You'll need to think about responsibilities. Who's responsible for each aspect? Who's going to be contacted in an emergency? Who signs off on any action? Since database recovery is only one part of your organization's overall disaster recovery, you'll probably also need to coordinate with other teams. To design and document your recovery procedures, you need to consider each possible failure that you can imagine, and then work out what impact that failure is going to have on your database and application, and how you would recover from it, including expected timings. Each category of application that you already defined with its different requirements will probably need different methods. We'll look at just a couple of possible failure scenarios and see what the thought process would be there. What happens if you lose your primary database node? With a high availability architecture in place, you'll encounter a brief unavailability, whilst the HA system detects the issue and performs an automatic failover to one of your standby databases. You'll have to replay any in-flight transactions, and you might lose data associated with some committed transactions if you're using asynchronous replication. The recovery time should be in the order of seconds, depending on the timeouts that you've got configured in your HA architecture. You'll afterwards have to do some work to rebuild your own primary and reintegrate it into your HA cluster as a standby, but that's done whilst the system's up and running, so it doesn't contribute to the downtime. So your recovery timeline might look something like this, with a very short unavailability. If you have a standalone database, you don't have a standby to take over if the primary or only database fails, so you'll need to restore from backup, and the database will be unavailable whilst you do that. If you're doing online backups of your database and archiving all of the WAL files between backups, you can have minimal data loss, as a general rule, a maximum of one WAL file. And recovery time is going to depend on various factors. It will depend on the size of your database, the speed of your disks, whether or not you have to set up a new Postgres node before you can restore, how much WAL needs to be replayed, etc., etc. Let's say your database takes 45 minutes to restore and recover. In that case, your recovery timeline might look like this. You've got 45 minutes there of unavailability whilst you wait for that restore to happen. What about if a batch process goes wrong? Say you have a batch process that runs at 7 a.m. to ingest files that were provided overnight. The process takes half an hour. At 8 a.m., you notice that something went wrong. Maybe part of the process fails, maybe some files were processed that shouldn't have been. If you're lucky, you've got a window between 7 a.m. and 8 a.m. where nothing else is going on in the database. On the other hand, you might have transactions going on in the database at the same time. Perhaps it's just a slightly quieter period. That's going to have an impact on which recovery process you choose to use. What are some of the options? Well, you could restore from backup and perform a point-in-time recovery to just before the batch process. You could recover to a separate server, export the impacted tables and import them back into your primary database. Or you might be lucky enough to be able to script the corrections, which obviously you would test on a copy of your primary database first. If there was no other activity during the batch process, you might be happy to take the whole database back to 7 a.m. just before the batch started. So your procedure might be an in-place database restore and point-in-time recovery. In this case, your recovery time is 45 minutes, and the database is completely unavailable during that time. You might then need to keep the application shut down for longer whilst you rerun the failed batch process, or maybe it can be pushed to tomorrow's batch window. If, on the other hand, there was normal activity on the database between 7 a.m. and 8 a.m., you probably don't want to take the whole database back to 7 a.m. and lose an hour's worth of transactions. There's a good chance, luckily, that the set of tables impacted by the batch aren't the same ones that are being accessed by the application. Otherwise, you probably wouldn't have normal activity going on at the same time. So in that case, you might decide to restore a separate copy of the database cluster from a backup using point-in-time recovery again, just before 7 a.m. You could then export the impacted tables from the copy and import them back into your primary database. So in this case, assuming that it's taking us 45 minutes to do that export and import of the data, the entire process takes longer than in the previous case. It takes 90 minutes in this case, but your database and application are still available throughout that process, and you don't lose the transactions that happened between 7 a.m. and 8 a.m. In general, a high availability architecture isn't going to help in this case. The changes applied to the primary will be copied over to the standbys, so you've just now got multiple incorrect versions of the data. But there is a workaround. You could create a delayed replica using the recovery min-apply delay parameter. Since your batch job takes 30 minutes, if you set that, for example, to 1 hour for one of your standbys, that would give you 30 minutes between the end of the batch job and the changes being applied to that standby, where you could check that everything had happened correctly. If not, you've got time then to export the good data, the pre-batch data from that delayed standby and re-import it into your primary database. Make sure every scenario is clearly documented and automated as far as possible, and test each scenario. You want to note the approximate timings of each recovery, because in an emergency, people will always want to know how long till we're back up and running. It's the disaster recovery equivalent of, are we nearly there yet? Then test again, just to be sure, and plan to test your recoveries regularly, and preferably have other people test them. And finally, the backup strategy that you're going to put in place to respond to all of those recovery requirements. For each category of application, you want to note the backup method. Are you going to do physical or logical backups, online or offline? Do you need continuous archiving? Obviously, as we've said before, you might need to be using more than one of those methods. How often are you going to take backups? Are you going to take a full backup weekly and then a daily incremental? Are you going to do a full once a week and then a differential midweek, for example? How long are you going to keep those backups? A week, a month, just a couple of days? Are you going to keep a week of backups online and then a year's worth offline, for example? And you need to include a policy for monitoring the backups to make sure they're happening as expected. You need to keep track of how big your backups are, how much wall you're generating. Make sure that there's enough space available on your backup volumes. Be aware of how long your backups take. Check that your backups are valid. I've had customers who found out during a restore that some of the files were missing from their backup set, and that is obviously the worst possible time to find that out. So now you should have a documented disaster recovery policy that includes a statement of your recovery requirements, the backup strategy that you've designed to respond to those requirements, the recovery procedures that you're going to follow in the case of failure, including expected timings, and a statement of who's responsible for each aspect. Putting that documentation together is far from the end of the story. You need to be performing regular testing of all of the procedures, and you need to keep the documentation up to date. I live in the mountains, and even though I have snow tires, I keep chains in my car all winter as a backup policy, just in case I get stuck somewhere. but there's no point carrying snow chains if you don't know how to use them. It's much better to practice putting them on calmly at home before the winter, rather than trying for the first time in a snowstorm in the dark in an emergency. And you probably want to practice that before every winter season, just to make sure you remember how to do it. For very similar reasons, you need to test your recovery strategy and plan to test it regularly. As a finger in the air type estimate, I'd say at least every 6 months, but preferably more often, and certainly anytime someone new comes onto the team. If you have to restore, it's likely to be an emergency. It'll be the middle of the night. There'll be no one around to help. There'll be irate users and managers desperate for the database to be back up and running 10 minutes ago. And there's a good chance that the person who wrote the recovery procedures left the company last year. You don't want to be trying out your restore procedure for the first time in that kind of situation. You want to have done it many times before. You want to know exactly what you're doing and how long it's likely to take. If you can confidently say, this is fine, or rather, I'm following X procedure, I expect the database to be back up and running in N minutes, and after that, I'll perform Y tests to make sure everything's as expected, then people might just leave you alone to get on with it. Review and update the policy regularly, at least annually or any time there's any kind of major architectural change. Requirements might have changed, tools might have changed, the database size will almost certainly have changed. So the procedures for testing, reviewing, and updating the policy should form an integral part of your actual disaster recovery policy. So your backup strategy is just one part of your database disaster recovery policy. The backups really are there to support your database recovery. First, make sure you've got well-defined and documented recovery requirements. Implement a backup strategy that responds to those recovery requirements for as many scenarios as you can think of. It might be with a combination of methods and tools. High availability architecture, online backups with continuous archiving, regular database dumps, storage snapshots, etc. Be aware that the database exists within a wider environment. Database recovery is probably just one small part of your organization's overall DR policies. Collaborate and communicate with other teams. Test and practice your recovery. Have a plan in place to make sure this happens frequently. And keep your documentation up to date to keep up with changes in policy, database size, the use, and any other changes that might happen. So the real conclusion is that you don't need a database backup policy, but you absolutely do need a database disaster recovery policy. Thank you so much for listening.
Right. Good. Thank you, Karen. So this is really a mindset, So if you think about just backup, you can forget about the recovery. But if you have recovery in your mindset, there's no way that you can do recovery without backup. So that one includes the other. So what do you think, Jelte?
Yeah, I think that makes total sense. Just to go back to the time I lost data, that was exactly because of not having the recovery in mind. Because we did have backups, but they were, well, the email account that said if the backups were working got like a email saying they were not working for like the last year, but no one was checking that email account. So
There's no policy.
That's yeah. And we never tried recovering, so that it didn't work, surprisingly, when we did try.
Well, I can imagine that gives you a very heavy headache, which brings us to the next topic. We were discussing yesterday about having a headache in a country where you don't know the medicine that you have to take, where you don't know whether it's an aspirin or a paracetamol, which is a very silly problem to have. And there are some much worse problems if you're in a really urgency and a life-threatening situation. What would you do if you don't know which medicine you can take?
Yeah, and that's what Taras Kloba is going to talk about. So let's just give him the stage. It's going to be amazing.
Hello everyone, my name is Kloba. I am Senior Solution Architect at Microsoft, and today I want to present a solution which we created for a tight NATO hackathon to advance drug search and also show how we utilize for this Postgres and Azure AI extension. Couple words about me. I'm a founder of volunteering IT group, which participated in Tight NATO Hackathon, and also we are the winner of this event this year. And maybe second reason why I'm today here also, I'm co-founder of Postgres Ukraine community, and I have been working with data for more than 14 years, and also have a couple of certifications. But a couple words about task which we received from NATO. They created challenge. This challenge highly important for NATO. They have this issue currently, and they invited some teams, participants from all NATO countries to participate in such hackathon and create some idea, create mobile application which will help them to solve the problem which they have. And in general, this year, my team, we were winners of this Tight NATO Hackathon and also received additional award like grant winners of this event. And a couple words about the issue which they have and how we decided to work on this. General problem which they have, that imagine the situation that new war starts somewhere, and NATO should send their soldier to specific region, and this will be soldiers from different countries, and everyone from them will bring their own medicine to this place. But it will be nice and wise to have the possibility to exchange this medicine between soldiers from different countries. And they need to have solution which will help these soldiers to find equivalents and use this drug and medicine and exchange between different units and people in such situation. And this was our task, and currently I want to tell and show how we decided to work on this. And we decided to talk to as much people as we can, and especially as I'm originally from Ukraine, I have really great access to paramedics and some experts from this domain, and these awesome people, they were our advisors, and they shown to us how we can solve this problem. And in general, like what we decided to do, we decided to create mobile application and also empower this mobile application with features and functionality available in Postgres. And today I will show you how you also can create similar application on your production environments inside your systems which you have. And this is just an example how we can utilize this feature available in Postgres. But to solve our problem, what we decided to do, and this woman, Inna, she explained to us how we can find these equivalents and how we can use for this additional databases which we decided to use in our system. In general, when you will take any medicine, usually on the top with a big font, you will see brand name of this medicine. But also with smaller font, and with smaller size, you will see some additional labels, and usually this will be the name of this medicine in Latin. And on this slide, I have example of this. For example, really popular medicine in the USA, this is Tylenol. But Latin name for this active ingredient is acetaminophen. And when we will want to find this medicine in European countries, for example, we again should go to this database, like to this data set, and look for brand names which have the same Latin label. And in this case, it will be much easier and possible for us to find this equivalence. And what we see here, that, for example, for Tylenol, we have this active ingredient in Latin, acetaminophen, and the same active ingredient is used in another countries, but with another labels and product names. For example, in UK, we have Panadol, yes? In European Union, usually name of this medicine, this is paracetamol, yes? And for example, in France, this is Dafalgan, yes? And this simple approach we decided to use in our application to create this matching and find equivalence. This is like example what you will see in our application. Also, we contacted Tata Kepler, and she has one of the biggest humanitarian center in Ukraine, and she explained it to us how important is to empower non-medically educated volunteers to also support in such activities. Because, for example, imagine situation that some European country or some another country, they send to Ukraine whole track of different medicines, and a lot of people will be involved into this sorting process to put each box and put into proper category, into proper basket. And for this, they also need to have like additional information, and we decided to add this additional information by utilizing ATC system and their catalog to show to our users name of category to which you should put this specific medicine which you will take. Also in our application, we decided to add additional use cases. We added like patient profiles to store this information. Also, it's possible like to share this information in specific obstacles, and these specific obstacles can be shown here. For example, imagine situation that someone need to have additional help, yes, and during providing this help and care, a lot of people will be involved into this chain. And first of all, like paramedics will provide some support. Yes, they should add this information to specific system, but currently by NATO standards and Ukraine also, this is written on paper cards. And imagine what can happen with these paper cards, especially, for example, in case of additional evacuations or additional cases. It can be really hard like to keep this information in safe place. And this is why we also decided like to include this information into our application, but added additional layer of authorization to share this information only with these people who have to have like this access to this information. And this also can be really important to save some lives, to share some important information, as for example, specific health conditions, for example, for people with diabetes, or maybe someone is pregnant, yes, and you can add this information and share even with enemies, because then proper care can be applied to this specific person, and it's possible to store and share in safe way this information in our system. But currently, I want to return back to our main topic, to Postgres, and how we decided to utilize Postgres in our application. And here you see overall architecture which we decided to create. And you should remember that we created this mobile application during a hackathon, and we had just 5 days. And this is why we decided to utilize as much as possible Azure services to speed up this process of developing our application. And what we have as a core of our search engine, this is Postgres database on Azure. And also, as you know, and you will see also a lot of another presentation from another speakers on this conference, that currently in Postgres you have nice extension, Azure AI. And with this application, you can create vectors for your information. You can also do nice things like summarization, and some advanced tasks also will be possible to do in this Postgres database on Azure. And we also decided to use PostREST to simplify creating of APIs for our mobile application. And also we embedded RAG chat assistant in our application, and I will show how we use this on the next slides, which I will have. But also, you should know that recently on Microsoft Build conference, we had chance to see new announcements about new features available on Azure. And for example, some of these components which were created can be replaced with more advanced technologies and with more advanced features. And for example, embeddings which we used on Azure OpenAI services currently can be replaced with the Azure Local AI extension. This is amazing functionality where you will have the lowest latency for creating embeddings, because this large language model will sit together on the same virtual machine as your database. And this means that you will have more predictable latency, you will do faster embeddings, and also you will keep your data safe, because they will not leak this virtual machine. And also you will cooperate and work with a local large language model on the same virtual machine. And second thing, things also presented recently is Data API Builder. And it's also really nice functionality where you just can create REST or GraphQL endpoints for your database, and also for specific function tables, storage procedures, all objects which you have, almost all objects of your Postgres database. But our solution was created like 2 months ago, and we just had the announcement of this feature on the recent conference, and just past weeks ago. And how we decided to create our solution, yes, and how you can create really comprehensive search inside Postgres database. Inside Postgres database, you have a lot of different operators to work with text, to work with full text search. But the simplest way, like it can be operator-like. Yes, but you maybe know that also in Postgres we have additional operator I-like, and this is the same operator as like, but you can ignore case-sensitive patterns with this additional operator. Yes, that usually like a lot of people, what they do, they like convert all information to upper text or to lower text, but with I-like operator, you can fully ignore case-sensitive matching, yes, and you will also always see proper results for your queries. And first of all, like we decided to add functionality, like to search with the beginning of the drug name, but it's also like example on this slide which I have, that you start to type something. Here I for example have example for Tylenol, but I just can type first 5 characters like Thailand, and then add the additional symbol, this %, and then Postgres will find for me all matching. And this is like the simplest operator which you can use to find proper results. Also, you can add this character of % on the beginning and in the end, and this will mean that you will try to find this searching input anywhere inside this column drug name. Yes, it's highly important also to mention that this is just example on this slide, but in general, we search on multiple columns, on multiple databases, and we also verify like descriptions, clearance, the symptoms, and other things which we have in our database. Second approach which you can use also to find some misspelling errors or maybe variations of something what your users try to find in your application is utilizing of trigrams. And for utilizing this functionality, first of all, you have to create and install additional extension on your database. For this, you just need to execute this command which we have on this slide on the top, like create extension pg trigrams. And then Postgres will split your input into a specific like array. Inside this array, you will have like a different combination of your input splitted by 3 characters. And then this means that with this approach, you also can find something what you have in your database, but with ignoring misspelling, and help the user also find something similar what they try to find. For example, in this example, which I have here, I decided not to look for Tylenol, but I improperly or maybe correctly misspelled name of this medicine and added something like Tylenol, not Tylenol, but Tylenol. But this still will work in our case. And you can see on this video on the right that even in this situation, we again can find our active ingredient acetaminophen and help to our users to identify something what they want to find. Also, we decided to utilize vector search. Like everyone currently are part of AI, and we decided to embed this functionality also in our application. And with Postgres databases, and it's really easy currently to do. And especially with additional extensions which we have for this, it can be really simple to do. Yes. General idea how this works is that first of all, you have to create vectors for this information which you have in your database. And then when your users will want to find some similar information, you will need also to convert their input into vectors and compare these vectors with each other. And with this, you will also find similarity even in case when any character, for example, is not matching, but meaning of these words are the similar. Yes. And it's a really powerful approach. And look, for example, which I have here, that in our application, you can type something like pill for pain management, yes, or you can type something like red pill from headaches, yes. And this also will work, yes, because these large language models will create embeddings with embeddings vectors for this input, and inside this multidimensional area your vectors sit somewhere close to medicine which you want to find. And this is really powerful approach, especially this can be utilized in stressful situation, because people in this stressful situation can forget specific name of specific drugs, medicine, but they can just type symptoms or describe what they want to find. And with utilizing these technologies, it will be possible to find proper match in this case and this situation. Additionally, we decided to add into our application chat assistant. Yes, this, for example, can be something like, sorry, this is this slide, I mean. Additionally, we decided to add RAG assistant. Yes, this works in way as a regular ChatGPT, yes, or another systems currently available. But we empowered this chat with information which we have in our database. In our database, we have more than 700,000 different brand names. And each time when someone looks for some specific information, our system, and usually in such way are created RG applications, our system will go with this input, first of all, to our main knowledge base, to our Postgres with all this information which we have, retrieve some additional information which we store in our database, like information about specific medicine, collect this information, send to large language model, and then based on this meaningful inputs which we have in our database, and also with getting information from original question, output will be generated, and this output will have some meaning for end users. For example, in this example which I have question to my chat, how much paracetamol should I give to my 15 kilograms child? And look, we identified that inside this sentence, we have something, what we have as drug name, as product name in our database. Then we can go, and it was like right path in this case. We visited our table, collect additional information about this medicine. And in our case, this can be something like 30 pages of text related to this product name which we have. And then all this information is sent to large language model. And based on all this information, our users will receive proper response to their question. And in our case, what we see that for 1 kilogram, you can use something like 15 milligrams, and then 15 milligrams multiplied by 15 kilograms give you 225 milligrams, yes? And it also can be really useful, yes, because maybe is in such situation you don't have access to doctors, yes, and you can receive this proper help from chat, and you will know that this chat is powerful with right and correct information which we store in our system. And in the end, we decided to combine this different approach which we have. That first of all, we rank outputs to our users and provide in first order information which we matched with operator like. Then we try to use trigrams. Then we try to use but with percentage from both sides, and almost in the end, when we cannot find nothing, we will utilize large language models and try to find similarity based on vector information which we have in our system. And this is really powerful approach which you can use in this use case. You can also find other use cases, and this can really empower your system to retrieve proper information about everything or almost everything what you have inside your systems. And I have additional demo about this mobile application, but what I think can be right in our case, you just can scan this QR code and launch this mobile application on your mobile phone and try it out. Also inside our application, we have additional feature about which I didn't mention during this presentation, because it's mostly not related specifically to Postgres, but also inside this application you can use your camera and find proper medicine based on photos or based on barcode which you have. Also, you can talk to this application, and we will convert your voice into text and also try to find information based on this. And also you can go through patient profiles and additional features which we have inside this mobile application. And I invite you to contact me if you have any question, and I will be happy to talk more and explain how this works and how you can utilize this approach in your mobile application. Thank you for having me.
Thank you, Taras. This was super impressive. It's always good to see people using Postgres and what they do with it in general. As a database engineer, it's sometimes hard to sort of lose touch with that a bit, but this is incredible. Well deserved prize on the hackathon for sure.
Absolutely, very useful stuff. Definitely, yeah. All right, so remember we still have some swag available, so make sure you enter your information so that you can get some of that nice stuff that you can also get in this online conference, not just for in-person conferences. And yeah, this is for you.
Yeah, and there's even more swag. You can also get sweaters and t-shirts, or hoodies and t-shirts, and yeah, as long as you participate in one of these two challenges for Azure Database for Postgres, one for AI and one for migrating stuff to Postgres. Yeah, go to the link, and if you participate, you can get a hoodie or a t-shirt.
All right. And so we were discussing earlier that you can have all this kind of stuff, which is super nice to show your love for Postgres. But some people even tattoo this stuff in their arm. It's quite impressive. And one of them is Federico, which we are going to see next. Now, he's going to be talking about ZFS. He said that it has bad reputation. Every time that I hear somebody saying bad reputation, I have to think about Thin Lizzy, this very nice rock song that they have about bad reputation. However, Federico, as a musician, he is more like in the jazz scene. He plays guitar and he plays jazz guitar. Very nice stuff. And as a real Italian, he also wrote an extension called PG Carbonara for the right way of cooking the carbonara. So you can also put that into your Postgres extensions, favorite one. Now, he also wrote a software called PG Chameleon to move data from other systems into Postgres. And as a real chameleon, Federico Campoli, he can be, as I said, a jazz guitar player. He can be a DBA. He can be a competing cyclist. He's really good at that as well. And also a fantastic speaker. So let's hear what Federico has to say about Vindicating ZFS.
Hello everybody, my name is Federico Campoli. I am a freelance PostgreSQL consultant, and today I will talk about PostgreSQL running on top of ZFS, a powerful file system but with a bad reputation. So if you are a sysadmin or DBA and you are searching for an alternative for performance and scaling up your system, you may be interested in my presentation. Thank you. Okay, so let's start with the Vindicating ZFS with PostgreSQL, unleashing the power of scalability. Before I start, I want to present you a little about myself. I look younger, but I was born in 1972. I am passionate about IT since the 1985. I'm in love with PostgreSQL since 2006, and I have a PostgreSQL and FreeBSD tattoo on the right shoulder. Not sure if it's visible, but I can show you there. So I am one of the two crazy people to tattoo PostgreSQL on our skin. So I am a freelance DBA. So let's talk also the way to get in touch. This is my LinkedIn account. This is my GitHub page with some of my projects. I'm also an amateur Python developer. This is my SoundCloud. This is contains mostly of my experiments with music, because I'm also an amateur jazz guitar player. And this is my blog. It's not exactly up to date, but I promise I will resurrect sometime. So let's talk about this particular talk. The talk is based on a real life experience. Of course, I cannot show you the information about the customer because it's reserved information, is under NDA after all. But I did some reenactments of the tests I had with the customer on a different platform, different environment and different volumes, but they are quite interesting. There are a lot of topics not covered by this talk. The time is quite short for presenting this thing, so I'm not covering entirely the ginormous amount of information you can get on ZFS. So consider this talk, as this presentation, as a starting point. So I want to stimulate your curiosity and maybe give you an alternative to the normal solutions you can find on Linux. And most important, always test before going in production. Things may vary a lot from one case to another, and I also discovered that the tests are are even better than the tests made at the customer. So always test before going into production. So our agenda, our table of contents is quite short. We are doing some context. So what happened to me when I worked at this customer, the key master and gatekeeper is a quote from the probably the most hilarious movie after Frankenstein, Young Frankenstein, in the world, so Ghostbusters. Some tests and some wrap up about the situation, the discovery we had through our tests. So the story about that you are about to hear is absolutely true. Names and other stuff are being changed to protect the innocent. So take this information as based on a real story. So what happened? This time happened probably 1.5 years ago. A long time ago, there was a startup far, far away. And that was running this Postgres on someone else's computer, also known as the cloud. And this database was misused, abused by the developers. And the result of this misuse, it was causing a massive bloat on this database. This is one of the problems we have in Postgres. The architecture of PostgreSQL is expose the storage to become bloated if it's not correctly understood, if it's not correctly used. And that was exactly the case. It costed a lot of money to the customer because the storage required an extra expensive storage class. So they called the DBA, me, and as my usual, I may look quite nice or funny, but sometimes I get incredibly harsh. And this is my approach when I get the problems. So this is Sparta. I usually start kitching out, screaming, and trying to find a solution because things should be correctly configured to make the database. Blaming the database, blaming PostgreSQL is not the correct way to approach stuff. So we had a lot of possibilities. We explored a lot of possibilities, and one of those possibilities was ZFS. Now, before talking into ZFS, let's talk about the fact that Postgres and Linux are not friends. Well, why they are not friends? Because there are two systems that are based on different paradigms, different architectures, and they were built on different starting points. For example, in PostgreSQL, we have a multi-processing system. So PostgreSQL is not multi-threaded, but is multi-processing. The block size, the default block size you may find into the normal installation is 8K, 192 bytes, and is allocating when you started our infamous and our friend the shared buffer. It generates one big shared memory segment. So expect that the memory is contiguous into the RAM, and it consumes a lot of memory. So what's the problem with Linux, our gatekeeper? Well, the Linux infrastructure is based mostly, the modern Linux infrastructure uses NUMA, and that means the memory pages are scattered around RAM. So when you allocate the shared buffer, it's not guaranteed that the shared buffer will stay in one contiguous segment. There is a way to force this behavior. The max file system block size on x86 architecture, so AMD or Intel, is limited to 4K. So it means half of the block size of PostgreSQL. So it means fragmentation. Dirty flash on Linux, the dirty flash is something that happens when you have a lot of writes to be flushed on disk into the kernel memory. When a dirty flash synchronous I/O happens, it blocks the I/O, and it seems like the database is blocking, but it's not the database, it's Linux that is blocking the database I/O in all together with the rest of the I/O on the operating system. And there is our friend, the infamous OOM killer, the OOM killer. OOM stands for out of memory killer. So basically Linux tends to overallocate, overcommit the memory. And this is, from a database point of view, is a bug. So Linux is not optimized for working with the database. But they can be gently pushed together and summon Gozer, basically. So how can we do that? We need to work on both areas, our keymaster and our gatekeeper, Postgres and Linux. In terms of PostgreSQL, we need to tune the max connections. Do not consume too many connection slots. Enable the usage of huge pages. The huge pages is a way for telling PostgreSQL to use an infrastructure implemented in Linux that permits to have a single shared contiguous memory segment into the RAM. Do not oversize the shared buffer. This is a particular point I've seen several times, in particular when working on cloud-managed databases. The shared buffer, after a particular size that is around 64 gigabytes, creates regression, not improvement. So do not oversize the shared buffer for another reason. The shared buffer is designed for optimizing the access on blocks, but the segments, the file segments are well managed by the Linux kernel cache. So let's work in tandem between the shared buffer and the Linux kernel cache. Do not allocate the entire memory to the shared buffer, because this is not going to work well. On the Linux side, disable or make NUMA less probable. Configure and use the huge pages, because you can tell Postgres to use the huge pages, but you also need to tell Linux to allocate a huge page sufficiently big to contain the shared buffer we want to set. And also configure the VM dirty ratio. This is the percentage of memory into the kernel cache that triggers a synchronous flash on disk, a blocking flash on disk, when is reached. The default value is very low. On some Linux is 20%, on another Linux is 10%. It depends by the distribution. But this value is absolutely dangerous, because it may end up with a large shared buffer in particular. It may end up with a blocking I/O on Linux. Disable the memory over commit, and disable the memory over commit is mandatory on database systems, and on supported architecture, set the file system to block size 8K. This is possible on ARM architectures. Or use file system more flexible like ZFS. And now we go into the file system part. So in the normal, we are discussing about XT4, but some of the concepts apply also to XFS. So in XT4, it's possible to optimize the file system at mount time. So disabling no A time, no dire time, it gives improvement when accessing the files, because the system, it won't need to update the access time for the files when accessed. So better performance. We can disable the barriers, the write barriers, skipping a little the safety for having more performance in write. My recommendation, and also the Red Hat recommendation, my recommendation about do not disable the barriers on the WAL area, and the Red Hat recommendation is do not disable the barriers on virtual machine disks. So because we are on virtual machines, we are not using the barrier 0. Using also data write back for the journaling improves the writes on XT4. So why considering ZFS instead of XT4? Well, because XT4, ZFS, it creates a massive architecture, a massive infrastructure for our system. In fact, is more like a database rather a file system. I like it a lot, even because some of the concept I found into PostgreSQL, I get the same concept into ZFS. So in particular, we have a pooled storage, we have the copy on write, we have the snapshots, we have the data integrity and verification and automatic repair with the scrubbing. We have an implemented and a built-in RAID when we have multiple devices, is RAID Z, and we can store up to 16 exabyte file size. And we can have 256 quadrillion zettabyte in storage with no limit of the number of file system datasets. Well, it's just numbers, just the upper limits. Of course, the limits that are imposed by the resources. The cons of ZFS. The license is not compatible with GPL, so it's not part of the Linux distribution. You need to install separately. It's memory greedy. It's basically a database, so it's memory greedy like any other database. The maintenance requires attention, is not very efficient in writes, but it can be improved. And there are some bugs that are popped up. In particular, this one is pretty horrible because under particular conditions, it can lead up with data corruption and loss. So always be up to date to the release notes and the mitigation if something comes up into the system, into the release. This applies to on anything, not just the ZFS thing. Options for ZFS. Another good thing about ZFS, you can hot configure ZFS. So you can, instead of applying the change, remounting the system, and maybe get some downtime because you had to shut down the database, remount, and so on. In ZFS, you can change these settings on the fly. Of course, the changes apply only to the newly written data. So you can set up the A time, disable on or off the access time, similarly to the XT4. You can change the record size. Record size stands for block size in ZFS. The default is 128K, but you can change it accordingly to your needs. You can enable or disable the compression, transparent compression. The default is LZ4, is gzip, and you can also use different algorithms like LZ4 or ZSTD. Yes. You can set a log for the intention log for having a preemptive way to managing the ZFS itself. And also, you have the possibility to configure the ZFS module, because it's a module, it's not part of the Linux kernel. You load the module and you set your parameters. You can persist the modules into the modprobe.d, but you can also write most of the parameters as a dynamic value using this format. So, as a last part of this presentation, let's do some tests. Because back in my day, we had only 640 kilobytes, and I'm old enough to remember that my first computer had 4 megabytes, and it was a huge amount of memory. Anyway, this is the system I used for the test. So I created on GCP an E2 IMEM28 with a Rocky Linux 9.3 and 4 attached storage systems, all SSD. One for the data area and WAL area. So I removed the I/O caused onto the WAL from the equation. So the other table spaces, XT4, ZFS, are completely independent. And also I added an SSD with the ZIL, the ZFS intention log. The system used for the test. The hardware is a Google Computer Engine IMEM8 with 62 gigabytes installed RAM, 8 processors, AMD EPIC 7B12, separate volumes as shown into the diagram, the XT tablespace on SSD, ZFS on SSD, ZIL on SSD, and no swap area. The kernel and the Rocky Linux, it was the 9.3. Rocky Linux is one of the distribution rebirth from the ashes of CentOS, basically. Kernel configuration, dirty background radio and dirty radio set to avoid any weird flash I/O. Dirty background radio, it keeps the flashing background constantly in background. The dirty radio makes very difficult to have a blocking I/O. The VM overcommit memory disabled, the overcommit radio 100, swappiness set to 0. Postgres setup, Postgres 16.2, shared buffer 1 GB, work mem 400 MB, max connection 100, and max wall size 5 GB. Using pgbench with the default, scaling factor 500, with 50 million rows on pgbench account, 500 rows on branches, and 5,000 on tellers. Number of clients 50, and one number of threads 1. Duration of each test 120 seconds. No foreign keys to disturb the operation. So pgbench initialization for each test. So the tables are recreated every time. So on XT4, the creation, it takes about 18 seconds. And after the run, we get this value, TPS 4900 transactions per second. Disabling the adding the no time and no zero time, it makes the operation slightly faster. The TPS jumps to 5300.72 and 71. Also, changing the data to write back improves it makes things slightly worse. So it makes basically no change. The value is similar. There's some fluctuation, but there's no big difference anyway. Let's see instead our friend ZFS. Now, on ZFS, with the initialization with no tuning, the TPS is 1700s. Is horrible. The performance, and it explains well the bad reputation of ZFS. But with A time off, so turning off the A time for that dataset improves a little, but we are still on what the... So how can we improve this thing? Well, at the customer, we try the compression using different compression algorithm. The first thing noticed is that the space used dropped from 7.4 gigabytes to less than 1 gigabyte. And also, the performance in terms of TPS, it jumped a lot. It becomes slightly worse than XT4 with no tuning. So we are getting better space and better performance. But we can improve this thing? Yes. We are still using the default block size, the default dataset size, record size. So if we set the dataset to 16K and we get, more space allocated, so less compression in place, what we get on GCP is TPS 6200s, better than the best on XT4. We can improve things. Yes, we can play with other parameters like the ZFS modules, disabling the flash, fixing the size of the ARC, disabling the TXG timeout. We can do this sort of stuff. Also adding the ZIL. But on my tests, the improvement was basically not measurable. The time, the number of TPS, even with this optimization, it still stay the same. Now, let's give you a quick display about the results. So in terms of space usage, the best is when we use ZFS with LZ4 with the default block size. With the in terms of load time, the load time is not very fast. The best probably is still on this thing, no A time and LZ4. So if we want to optimize our ZFS table space for batch load, maybe we want to consider this particular option. In terms of latency, the best results are found on ZFS with no A time with a record size 16K. the latency between the not optimized and the optimized with Zeal are basically similar, so there's no big difference. And in terms of transaction per second, the best are, the winner are with the record size 16K and the compression enabled on LZ4. So we are almost at the end, so let's wrap up. We can get good performance on ZFS despite the bad reputation. We need to look after any weird bug appearing, and always use the PostgreSQL block checksums, and always use the right tool for the right job. So no ZFS if you have a 20 megabyte database, and always RTFM. This is very, very important. And finally, remember that your mileage may vary. This is a picture of the best car even built, the Panda 4 dry wheel. Is unstoppable, but he has no airbag because we die as heroes. So we are at the end of the presentation. I hope you can get it as a starting point, and that's all, folks. Any question, please?
Yeah, that was great. Thanks, Federico.
Yeah, very interesting. I mean, the important thing about tuning is very a key stuff here. I mean, because the same file system without tuning, it didn't do very well. And then in the Discord channel, we can see guitar being tuned as a message from Federico saying, like, yeah, you see, you need to do this stuff.
I mean, if you care about the performance, if you just want to store some,
exactly.
If you have like a tiny database and you don't care, that maybe you don't even need to, but yes.
But I mean, if we look at the talks that have been presented in the live streams, there are many of those that are about tuning, and one about not tuning the database, but tuning the query. So this tuning stuff can happen in different places. So you have to see which one is the one that is right for you. So file system, Postgres, queries, a lot of interesting stuff. So
yeah,
very impressive conference, I would say.
Yes, very much. All right. And so, yeah, there's lots of talk about this in the Discord channel, so go there. Federico is answering all kinds of questions. And we have another trailer for like the second live stream of this week that was already happened. You can watch that back. So there's now a few trailers of all the speakers, and you can find out if you want to watch those videos back. You probably do, because they're awesome.
Hello, I'm Regina Obey, and today I'm going to talk about the open source geospatial community, Postgres, Postgres, and how Postgres joins the two.
Hello, I'm Heikki Lindenäs. I've been working on Postgres and traditional databases for a long time. Today I'm going to talk about the vector data and how vector data is different from other kinds of data.
This talk might be interesting to you if you happen to work with PostgreSQL, if you want to learn how to employ recent developments in machine learning models into your PostgreSQL applications.
I was a former intern in Citus in 2022, and a part of this talk will actually address a part of the work that I did as an intern in Citus. Mind you, I was completely new into databases. I never heard about PostgreSQL, and I barely knew anything about any software engineering practices. So if you are also a beginner, please stay tuned for this talk because it might be interesting for you.
Hello everyone, I'm Marcos Lotz. I'm a software engineer at Crunchy Data, and I'm going to be talking about data-intensive Postgres, 3 ways to scale, or rather 3 different types of workloads that you might struggle with on Postgres if you have a data-intensive application.
Hello, my name is Silvano Coriani. I work in the Azure Postgres team, and I'm here to present about high availability and disaster recovery for Azure Database for Postgres.
So I'm Chris Ellis. I'm kind of head of technology here at Next Team, and at Posette 2024, I'm going to be talking about JSON-B with Postgres still needs some form of schemas, right? And this is a talk very much about dealing with those kind of situations where you don't really know what data you're storing all the time, or you're just dealing with kind of quite complex data structures that you don't really want to just map into tables.
And the story that we are going to see is not the typical presentation with the slides and bullet points. This one is a storytelling, so it's a different format. And we were going to go together with Monica De Bea, a tremendously talented support engineer who is going to investigate together with Kevin and Derk about a problem that Derk has with his project with synchronous replication. So we are going to go step by step until we find a solution to Derk's problem.
And we're going to be discussing neurodiversity and how it affects interactions within the workplace and the IT community in general.
And I had just given an internal talk about my ADHD diagnosis and how I've been basically coping with something that I, had all of my life, but I only found out about fairly late in life, right? And asked if we could do a talk about it together. And we talked some more and figured we should submit something to Posette.
Today my talk is about how we can accelerate migration to Postgres on PGSQL when we are migrating away from commercial engine like Oracle or SQL Server.
Hi, my name is Ryan Booz, and I'm excited to be talking about PostgreSQL partitioning at Posette this year. Now, as our databases continue to explode with more and more data every day, partitioning is key to really understanding how to manage both performance and maintenance of your database. And I can't wait to talk to you about it.
A lot of great content there. I mean,
yes.
My favorite talk. I'm going to use my superpowers as co-host here, and I would like to invite everybody to watch Jimmy Angelakos and Floor Dress. That talk was really, really interesting and opened many, many eyes. So I think it's a very good thing to check.
Yeah, for sure. Go watch that one.
Yeah, and unfortunately, we come to the last talk of this conference, so we need to wrap it up. The good thing is that we can continue with some of the things that we have seen already before. Italian presenting jazz musicians, because Paolo is also a fan of jazz music. Actually, he's going to be talking about Django, which is inspired into a Belgian guitar player called Django Reinhardt. All this kind of stuff is the fundamental interconnectedness of all things. So we are also been watching all the interest into artificial intelligence and Postgres, and he is especially going to be talking about pgvector, which enables all these kind of things that you can do with machine learning and embeddings and stuff like that. But I will let him to talk about this stuff because he's a nice expert about Django, Postgres, and pgvector. So let's give it up for Paolo Melchiorre.
Hi everyone, I'm Paolo Melchiorre. I'm the CTO of 20Tab and I'm a member of the Django Software Foundation. I use Django since a long time to do my web project, and today we'll see together how to integrate semantic search using Postgres and pgvector. You'll find these slides I are sharing to you on my website, paolox.net. And for starting, we'll see the final results of our work today. This is the Django admin interface. As you can see, I just performed a search using a word and every results with different words, but with contextual meaning related. But to do that, I want to present a bit myself. I'm Paolo Melchiorre. I'm a member of PSF, TSF, and Python Italia Association. I'm Python Italia co-organizer and founder of Python Pescara Meetup. I'm also a Django contributor and coach of Django Girls. I use Django for my project, and I know this is not a Django-related conference, but I want to introduce a bit this web framework. Django was named after the Django Reinhardt guitarist, and it's a web framework with a lot of history, but it's also very flexible, and I use it for all my projects. The motto of Django is the web framework for perfectionists with deadlines, and since its original creation and the next public release in 2005, a lot of feature was added. Most relevant for us is Python 3 support, the addition of a specific Postgres module with specific feature, the ASCII support addition, and in 2022, the addition of Python 3 support. There are other web framework you may know, you maybe already use it, like Flask is a Python web framework, very common, and it's very easy to use. This is a code from the quick start of Flask. As you can see, with few lines of code, you can instantiate Flask and declare a function to return HTML. There are another new Python web framework that is very common and very trending nowadays is FastAPI. In a very similar way as Flask, you can see we have able to declare an asynchronous function and return JSON in a RESTful endpoint. I did an experiment with Django. I created this micro Django demo and DjangoCon US 2023. As you can see, I used the same approach of the Django, the Flask and FastAPI quick start to declare an endpoint to return an HTML using a WSGI handler. In a similar way, using an ASCII handler, I declared an asynchronous function that returns JSON response. I used Django to perform the same quick start as Flask and FastAPI, but it's only to demonstrate that it's very flexible and it's very convenient to use. And we're going to use Django initiating its project in a proper way, using its command. Before to start, I want to show you the code I'm using to perform all the steps on this workshop. And the first thing I did is verify the Python version and create a virtual environment and activated it. And inside it, I will install Django. After it, we can start creating our project, moving our project directory and using the start project command. I named my project Semantic Search very originally, and you can see below it all the file Django created for us with some settings, URL, and asking a WSGI file. After that, we can enter the just created directory and start a new app. I decided to create an items app, and Django created for us all the necessary file for the models, the view, the test, and also the admin. And now we can add these new created items in the settings in the list of the installed apps. The apps before are all from Django itself, and they are usable to have the admin, the session, and other fundamental parts for our project. So after this initialization, we can start writing real code. In this case, I decided to create an item, an example of an item, very simple, with a textual content, and I declared all the fields I needed below inside the class. I decided to create a price integer with a default and a stock Boolean field with a true as default. I also declared a string representation for this item and with returning the content, the textual content. After declaring our class, we need to apply all this new information to the database. To do that, we can use the make migration command in Django, and we can apply the migration to it with a similar command. But to see what Django is performing for us, we can use the last command and decide which migration file we want to show. And this is the SQL code that the Django ORM will create for us and apply in the Flow database. In this case, this is the SQL code that was created for the SQLite database, which is the default for a Django project after we created it. As you can see, we have all the column for the field we declared before with the its type and its default. And we have also a primary key. It's a default column Django create for us. Now we can perform some queries on this table. To do that, we have to enter the shell of Django and import the new created class. And with the filter function, we can perform some lookup on different field of the model. We are searching content in a case insensitive mode, and we can perform a filter on the price and on a stock column. We have a list of item representation, in this case only two items that contain the string rock in its content, rock and rocket. And this is the SQL generated by the Django ORM on SQLite. It's a select all on the item table with the filter below related to the filter we just did in the query. But there is a way more convenient to query and interact with this new created class. And as I show at the beginning of this presentation, it's the admin. The Django admin is a crude interface to our database. Its purpose is for development and local usage. And you can declare an item and it can create your form and interface for you, but you can also declare some attributes. Like in this case, we decided to show some filter, to search on some content, and also to show the facet or its interface. To see this in action, we have to create a super user with the Django command in the command line, and we can start the local server using the run server command. And this is it, the creation form for the item class. As you can see, we have the widget for all the field we declared, text area for the content, number input for the price, and a checkbox for the Boolean is stock. We can create through this form few items, just as I did here, and Django will start to show us the filter with faceted contents, and it shows also the representation in a table like this with the input search over it. And we can use now all this filter to perform a query on the Django admin. We performed the same query as before we did in the terminal, searching for text rock in this case, and we had the same results as before. You can notice that we have a Django debug toolbar button on the side, and if you click on it, you will show what it's performed under the hood by the Django admin. Here you can see the SQL representation, the timing, and also the query plan for that we just performed. It's very similar to what we saw on the terminal before, and it's very convenient to debug locally and to see what is not going well in your query in the admin. But now we want to start using a very specific Postgres feature, and to do that we have to install PsychoPG. This is the Twitter account of PsychoPG, and to install it, it's very simple. We can install the binary version of the module because it's very convenient for developing purpose. After that, we have to update our setting file in the Django project to add a different engine, Postgres 1, and we have to add all the required parameters to connect with the database. It can be local or remote or in Docker or similar one. Using Postgres is the same as using SQLite. It can be more performant, but if you want to use a very specific feature of Postgres, we have to add the Postgres country module we set at the beginning to use it, and we do that in the list of installed apps. In this case, we come back in the shell. We try to perform the same case-insensitive search as did before, and using a plural word instead of a singular word. As you can see, in the query set is empty because there is no word. We created it contained the text rocks. But in the second query, you can see we just performed a filter with the plural word and we had results. This is because the search lookup performed a full text search using the full text search of Postgres below. In fact, this is the SQL code of the Django ORM generated from the search lookup. As you can see, it used the plain to TS query on the input text and to TS vector to the item content. This can be very slow because it's performed live, but we can also decide to create a vector, in this case as it's generated, and it's persisted on the database, and this field converts directly the content field in a vector for us. And after that, we can perform a full text search very, very easy. Same as before, we created the migration, and we can see the SQL code under the hood. We alter the table item, and we add the column vector, that is a TS vector generated, and it contains the vector from the content. But we are here to perform a more advanced type of search, a semantic search, that you can find different type of definition. Under here, do we want to search for content and text that are not similar but have the same contextual meaning of the term. To do that, we need an embedding system that transforms our data in a vector embeddings using other embedding models. The vector embeddings can have different type, different dimension. In this case, this sample representation only 3. It's easy to think to the vectors as a 3-dimensional vectors, because especially we can see that the vector of our words or from example can be more or less close each other. And we can also understand that using a cosine distance from this to these vectors, we can find very easily which one is more similar, and so perform a semantic search on it. To store all this vector, usually is use some vector database. Quadrants is very well known, and it's open source. It has pros and cons because it's very popular. There is a lot of resources and example online, but on the cons, you will require a driver to use it, and there can be synchronization issue. This is a representation of the user interaction in a web project. When the user performs a request on your web project, and usually you interact with the vector database, and then you go on the database to take all the relation data. And it can be that in some time the database and the vector database cannot be synchronized each other. To solve this problem, if we already have Postgres in our stack, we can use pgvector. pgvector is an extension for Postgres, and to use it from Python, we have to install the pgvector Python module easily in this case, and there is no dependencies. But to activate at this point the pgvector extension in our Postgres database, we have to create an empty migration, and we have to edit this file just created for us by Django, and add only this operation, the vector extension operation. We can apply this migration, and we can also see what he did under the hood in a very simple way. He created the extension vector in the database. At this point, we can start using the vector field to store all our embeddings. As you can see, we defined some dimension and we declared not editable. Same as before, we create the migration and we apply it, but we are very curious, so we go to see the script code under the hood. It altered the table, it added column embedding with a specific dimension and not nullable. Now to transform our code, our text into vector, we need to access some model, and we can search in some model system hub. In this case, we decided to use a sentence transformer. You can install sentence transformer very easily from pip, but it required a lot of dependencies. I removed from the log here because it's very long. It can took you seconds or minutes to install, but at the end you will have all you need to transform your content to embeddings. And finally, we can use it on our project. As you can see, we imported the sentence transformer and we initiated an instance of it. We decided in this case to use a multilingual model because it can use also Italian and other languages. And after the initialization with this very short name variables, we are going to perform something you don't need to do very often, is override the save method of the models. It's a model you already have in your models because you declared you already declared your class starting with the models. And the only things we added here is to use the encode method of our sentence transformer instance to transform our self content and to assign the results, the vector results, in our embedding field. That's it. But we already have created some instance of items in the interface, and to update them and to populate our embedding column, we can perform this query on the Django shell. We have to import items, and cycling over all the item instance, we perform a save that will use the code we saw before. Now that we have stored all the embeddings in our instance, we have to perform a query on it. So we declare a class method. It's only to example purpose, and the attributes of this method is a query text and maximum distance. We decided to put a default years. We are using the cosine distance function from pgvector, and it performs this cosine distance on the embeddings column and on the encoded version of our query string. And it calculated the distance from these two vectors. It returns our results using the distance to query, to filter all the items, and also to order them by the distance. So we can see only words that have more than that have a distance specific, and starting with the closer one. We can see in action in our Django shell here, and as before, we imported the item and we used the search method using the same word we used before. But in this case, we have results with words that are very different, but with the connection with the meaning, a similar meaning based on the context, like stone, rock, or music. Under the hood, it performed this select query, and it used the specific syntax of pgvector to perform a cosine distance and to filter distance under certain amount, and use also the same syntax in the order by declaration here. But we want to use it directly in our web interface, in this case, only the Django admin interface. And to do that in a similar way as before, we have to override the default method, is the get search result method. And if a term is inserted in the input text, we chain the query and the other filter in the query set with the model search method we saw before. It integrated both the filtering and the search term, the semantic search in it. And we are back. We are in the first Django admin screenshot I took before. As you can see, we performed a search of a word creator, and we have results with text very different from it, but with a contextual meaning connection with the original word. For this demo purpose, I only used a singular word, but you can put in it very long text, books, or what you want to perform a search over. And you can also use a regular web interface, not only the Django administration. But I use the Django under because it's very easy and fast to try to use a method and a function and perform query. And you can, from this point, start using this code to create a different project. You can use this code in this presentation because it's Creative Commons licensed, and you will find this presentation on my website, and you can also find other articles or posts based on Postgres, pgvector, and semantic search in my website or in my social accounts. Thanks again for me. I hope you enjoyed this talk. See you next time. Bye.
All right, thank you very much, Paolo. Appreciate it. And now for all the people who want to start using pgvector together with Python in the Django framework and PostgreSQL, then we will have a starting point with this presentation of Paolo, who explained in the Discord channel that he will put the code available and the presentation as well, so in his own site. Yes.
Yeah, I always love that. If you have a presentation with some code, always good to have it somewhere so people can look at it. Benchmark code is also super useful to share, just so people can play around.
Absolutely. So in the end, is it?
Yes, just sad. I mean, it is kind of sad, but I'm also getting hungry, so it is.
Time for lunch.
Time for lunch, yes. Yeah, for all the speakers, they're not allowed to get lunch yet. They have to stay in the live stream channel. So please go there. They have to stay until all of you people watching leave.
Yes, they have to answer your questions.
They have to answer your questions. So go there, get your questions answered, and please fill in the survey, the talk survey and the event survey.
Yeah, exactly. I mean, I haven't finished with the event survey now because we are not done yet. So I want to put it at the end. And I catch up a lot with the presentation of today. So I just need to put in my feedback for Paolo, but I did already for all the other speakers, plus 2 or 3 from the previous day. So Jelte, how many have you done? I've done 12 already.
I mean, you're definitely much better at this than I am. I think I got 6 now.
6.
But
it's not bad.
There's a few more that I want to fill in for sure.
I wonder if people in the Discord channel can also explain how many feedback they provided. That would be good to get that.
That would be great to see. To see if it's just us two giving feedback or if there's others giving feedback too. I hope it's not just us.
Wait. So Teresa is telling me internally that today we got a lot more feedback reviews than the previous live stream. So I think that we did a good job.
All right,
Jelte, promoting
that's
people
awesome.
for providing feedback.
For anyone that is now providing feedback, if you watch the talks from the other live streams back later, please provide feedback to them still. You can. I think the feedback form is open until next week somewhere. So even if you don't watch them today or tomorrow, you can provide feedback.
Yeah, and in the event feedback, you can also either complain or say that it was a good thing to have the two of us doing this live stream, that we come here by accident because everybody else canceled. But I think that you did a great job, Jelte. I'm super happy to share the stage with you. It's been
it was super fun.
It's been fun. Yeah,
it's been super fun. And so
what's next after this? What is going on?
Well, like we already said, the Discord, the feedback, and of course, you can watch all the talks that you missed. There's this aka.ms/Posette playlist link that has apparently there's all the videos or it has all the live streams. I'm not super sure yet. I haven't been there, but you can go there and you can find out what to watch.
Yeah, I think there are 2 ways actually to get the 2 ways of getting to the presentation. So you can go either to the website and then go through the schedule and then pick up the one that you want to see, or simply go to the playlist and enjoy it again in the order that it was presented during the live streams, starting with the keynote, with fantastic 4 keynotes that we had, and then going through all the other talks during the day.
And so we also have a podcast coming up soon, like next week, Wednesday. It's called Path to CytusCon still, but that's going to change very soon. I think we'll have the next slide on that. But it's basically like this, but without the video. It's talking to people in the Postgres community and hearing about how they do things.
And this next episode is definitely going to be about how to organize this conference. I mean, if you enjoy the content online and you want to understand what all the things needs to be done, how to contact the speakers, how to make that the slides are in good format, the quality of the video, the quality of the audio, people making jokes that you need to kind of calm them down. So all this kind of stuff that you need to do to organize such a nice conference is going to be explained by Teresa and Aaron in the podcast hosted by Claire Giordano.
Yeah, I'm definitely gonna watch that one because honestly, like it's kind of weird that Teresa especially, she's been behind the scenes she's been working tirelessly on getting all the things ready and good. But I mean, none of you have seen her. Only us behind the scenes have seen her. So it's normally at a physical conference, like the organizers walk around at least. But in this digital format, it's even weirder. There's you don't even see the organizers necessarily as a participant.
Yeah, and in person you will see them like with a T-shirt, like I'm the organizer.
Yeah.
Here you just don't see Chris as yeah. All right, excellent. But then, if you want to see some in-person events, what will be next?
So there's a PG Day Swiss or Swiss PG Day UK, and PG Day Lowlands, which is new. It's going to be in Amsterdam, so it's super close for me. And PG Ibiza or IBC, I don't.
Ibiza.
Yeah, the one in Ibiza, exactly. At least.
Unfortunately, there is a little bit of a congestion there in the date. All the last 3 are starting in September 11, go till September 13. Now, if you want for the sun, you can go to Ibiza. But if you decide to go to UK and Lowlands, the good thing is that, for instance, I live in Belgium, but if I need to go to Amsterdam, I need to take 2 trains. But if I would be in London, which is probably I'm going to try to be there for PG Day UK, only one train is needed to go from London to Amsterdam, and then you are ready for these two nice conferences. Swiss PG Day also very well organized, and Ibiza is coming in Spain with the sun. Call for paper is still open. Yeah. What next?
There's even more. There's PGConf NYC in New York. So for me, that's a bit far away, but I mean, for people in the US, it's closer than PGConf EU, which is again much closer for me. But and PGConf EU, you can still submit papers. Both are end of this year-ish, like end of October, end of September. So yeah, if you have some interesting talks, or after watching all these talks, you're like, I could do that. It doesn't seem so hard. They seem to have a fun time. Let me try it out. You can submit a proposal to PGConf EU.
Yeah, absolutely. Those conferences have very, very good reputation, so it's a good thing. All right. So about reputation.
Yeah. If you want some more online content, you can listen to this podcast. Actually, this is not even the podcast. This is previous content.
Previous conferences, yes.
Previous conferences. So yeah, you can watch those back. Most of those talks are still very relevant. So definitely worth checking out.
Absolutely. Yeah. Very good reputation, this conference. Change of name, but I mean, the reputation is still the same. Yeah. So time for bingo.
Yes.
How many of these talks did you watch, Jelte?
I definitely watched a lot of them. I didn't manage to watch everything yesterday on the previous live stream because I was very busy. But they're still on my list to watch some of them for sure. And I did watch a bunch of them. But today I watched all of them, so I got a good bulk of them.
Yeah, 42 talks, I think 44 speakers, and 46 in the global arrangement about between keynotes and type of talks. Very nice stuff. I mean, at least I think that I managed to do like 85% of the talks that I watch. I was able to provide the feedback for the speakers because they needed to get better. And I need to just complete the last 3 or something that I haven't completed yet. Yeah.
I think I finally realized why they have 42 talks instead of 44. Because now there's 2 talks with 2 speakers. So you still end up with 44 speakers. So you can fill this nice rectangle of 4x11 and it doesn't look slightly off because you have 2 speakers left over. So you want some talks with multiple speakers. I think that might be it.
The other reason is that I think that Claire and Teresa, they realized that we were going to be talking too much in the live stream 4. So they say there is no time for giving 11 talks in that one because these guys are talking and talking and talking, and people just want to go and have some lunch. But despite the fact they picked the 2 of us to be here, so I think it's time to thank the organizing team, the R team, the pirate team.
Yes, it definitely is. So all the pirates, Teresa, Aaron, Ariana, and Aaron, we're very glad you all organized this. It's
great job, absolutely.
It's a great job, yes.
Really looking forward to that podcast to get all the details. Are they going to give us some kind of secret stuff, some information that they shouldn't be allowed to present, but because it's a podcast, they're going to say like, okay, this information is kind of a nice disclaimer.
It can't be on video, but it can be on audio. So then it's
fine. Exactly. Yeah, like absolutely. Yeah, I mean, looking forward to that. All right, this is the end. Okay.
Yes,
well,
it's a shame.
But I mean, there's going to be next year, I think. Yeah, I hope that they invite us again.
There will be a few next year for sure. So
yeah,
thank you for joining this live stream. And if you want to watch some more, check out the Ultimate Guide so you can find out what talks you really want to watch and which ones you think are a bit less interesting for you, maybe. So this way you can sort of sort them by your own interests. So yeah, it's aka.com/Posette guide. There's more. There's all kinds of topics. AI related ones. Postgres core stuff. Core stuff, really down to the bare bones. Stuff about the ecosystem. Stuff around Postgres, extensions, connection poolers, lots of other PostGIS, lots of other things, and some stuff about Azure database for PostgreSQL on the one on Azure, and some stuff about the Postgres community.
My favorite talk is here.
The people,
in this, category. Yeah,
the people that we're working with. And like we said before, there's this podcast that you can go watch. But there's lots of more episodes that you could watch back as well. So not just the one that's coming up, but also the ones that are already there. Some of them are really good. Derk, who did a talk today, has a nice episode there. That one I know for sure. So yeah, go to aka.ms/path to CytusCon. Oh yes, this is. Do you want to tell the story, Boris?
Yeah, well, when we had the first meeting with all the speakers about who are they and what had motivated you to be here, for some reason, everybody has chickens. So there might be some mysterious way about taking care of the animals that kind of give you maybe more proteins or something like that. So that kind of fit your brain into good ideas for giving a talk. And this is how you become a speaker at Posette. Now, some of them, they must admit that they just wanted to have chickens. They didn't have chickens, but maybe just the will of having them, it is enough to get into very good submission. Maybe next year it's just going to be people having elephants or python snakes in the house. Who knows? Who knows? What is the future for Posette? We don't know.
And yes, there was recently there was also PGConf Dev, which is like the developer conference, the yearly developer conference for Postgres. It was in Vancouver. I was there. It was really great. Really good talks, really good discussions in the hallway with lots of people, and some really great keynotes. It was really good. And Andres was amazing. He had this. He got a cape for being a superhero developer because he saved us from the XZ exploit thing. So he was not happy with all the attention, but and that's why the organizers gave him an actual physical cape.
Was it an invisible cape? So that when
no,
he
like a real cape, like a physical cape, like a superhero cape with on the back superhero developer. It was very good. So yeah, we had all the live streams. You can watch all of them. You can watch all of them back. Still be nice, even in the chat right now. And we'll have all the captions. So if you couldn't follow some of the English in the videos, on the recordings, you can watch them in your own language.
Yeah, 15 languages right now. And this one is outdated.
Okay,
it's not
it
14,
depends on your language.
languages.
There's maybe some that you can't watch in your own language if you're not one of those 15, but it covers a very broad range of languages for sure. And follow us. They're on everything that you have. Mastodon, Posette. PosetteConf. Follow PosetteConf on Mastodon, on X, or on Threads. So yeah, follow us and see what happens next. Because next year you probably want to watch the videos again.
Yeah, shout out to the program committee who selected all these talks, and they did it in the most community-oriented way, and everything is explained in that fantastic blog post about the process of getting the program, all the submissions, how they accept it, how they select them, how to build up a very nice lineup. So very good.
And yeah, also congrats to us, I guess, to us and the other hosts. We're sitting here, sort of making some light banter between all the talks and keeping you here even after all the talks because you want to watch us go through all these slides, which apparently are much many than I thought they were.
Yeah, and we hope that there are some new co-hosts that are going to get sick or we have to cancel so that we can come back here to this very nice conference, PosetteConf, organized by Microsoft, but for the entire community. Super happy to be here helping from EDB to be a part of this nice community of Posette. Yeah.
And I think this is the last slide. So yeah, it's
It is.
That's
bye everyone.
That's a wrap, I guess. Have a
it is
good
a
day,
wrap.
have a good lunch, and
exactly.
And enjoy
See
some
you
more
next
videos
time.
tomorrow or after lunch or whenever.
Bye everyone. Cheers.
Bye bye.